Hello students, welcome to IMS GATE Academy. My name is Gopal, but today my session is on analog circuits. But the quick revision is done through formulae here. But I will select the total number of the chapters from the analog circuits. Within the span of 4 hours, we are going to complete the whole syllabus. Just based on the formulas only, we are going to complete the total syllabus only. But here I am going to explain the concepts of the each and every one of the topic also clearly now. Understand now. Yes, now we can enter into the subject only here now. But from the students, what I would like to expect is your focus on the subject is more important. Try to put the focus on the subject. These are the 4 hours only now. That's my kind request. Understand my point now. But the focus also what? Laser sharp focus is required from the students only now. That I am expecting from the students. Understand now. Yes, we can start. So what are those topics we are having in the subject of analog circuit? That is more important. Diode circuits and also biasing of the transistor. Next one, small signal amplifiers and feedback amplifiers, and also we are going to do operational amplifier, MOSFET. And these are the topics I am going to touch, and concepts also clearly given here. Understand now. Yes, we can enter into the subject now. The first topic I want to select is diode circuits. This is the first topic. But here the analog and EDC has got some difference. Whenever suppose you selected any component like diode or transistor or anyone, when the discussion is made internal structure, internal parameters, then the subject of EDC enters only. But in the analog circuit, we are not going to discuss internal phenomenon of any component. Just we are going to discuss external applications of what? Any device or any component. That is the work will be done in analog circuits only now. But here I selected diode circuits. The diode can act as a diode will be useful in number of applications only now. In the clipping circuits we are going to use, in the clamping we are going to use, even in the rectifiers also we are going to use, even in the designing of the filters we are going to use diode circuits now. That's why I want to start from the what now? Clipping circuits only now. In before we start the clipping circuits, certain fundamentals are very important now. Those basics I will explain, then I will start the what now? Clipping circuits. What I want to explain here is, in the GATE exam, you will find mostly ideal diode and non-ideal diode. Only these two diodes only we are going to find only now. Ideal means we know very well, when the internal resistance of the diode is 0, we will say it as a what no ideal diode. Whenever there is a, that means, but in the ideal diode we are going to find the voltage drop of 0 only. Why? We considered internal resistance is 0 only now. Whenever it is taken non-ideal diode, the voltage across diode will be considered as a what now? Some voltage only now. That is a diode voltage we are going to consider only now. Understand my point here now. Anyhow, what I wish to say, I selected ideal diode for example. I selected ideal diode. When we can say the diode is ideal means, but how the characteristics of the ideal diode means, we can draw like this. Voltage across the diode, I want to put the symbol of VD. The current passing through the diode, I wish to take it as ID, current through the diode here now. In the case of ideal diode, the characteristic curve will be plotted in this way. Just on the surface, it comes like this only. It comes like this only now. What is the meaning of this? Suppose I selected a diode This is the symbol of the diode, we know very well. In ideal diode, I said drop across the diode will be considered 0 only. When diode is forward bias, catch my point. When diode is forward bias, when we can say diode is forward bias, anode voltage must be greater than cathode voltage. Then we can say diode is forward bias. Anode voltage is less than the cathode voltage, we are going to say diode is a reverse bias only here now. In ideal case, whenever the diode is forward bias, it is replaced by short circuit. Directly you can replace by short circuit only now. That means the drop across this diode is what? 0 only possible here. This is 0 value. Voltage across diode will be 0, where in ideal case. But current through the diode is greater than 0 value possible. Once the drop is 0, the current is going to increase only now. That means if it is a forward bias, if diode is a reverse bias, this is for forward bias I said. If diode is reverse bias, I selected here now. If it is reverse bias, diode can act as a what now? Open circuit. You must take this diode can act as an open circuit only now. When diode is acting as an open circuit, it doesn't flow any current. It doesn't flow any current. But voltage will be what? Voltage will be what now here? But that means what we are finding, you see now the current across this diode first we can take now. Whenever it is an open circuit, current through the diode will be 0 only possible. That's why we are finding here what now? 0 current only now. But it can exist the voltage only. That voltage will be negative voltage only possible this side. Only negative voltage is possible. This is for ideal diode. Understand my point now. In case we selected non-ideal diode, for non-ideal diode, if it is a non-ideal diode, the characteristic curve is plotted in this way. That means this is nothing but voltage across diode. This is nothing but current passing through the diode. For non-ideal diode, if you are given in the problem, suppose you found in the problem, diode is forward bias. Whenever diode is forward bias, it must be replaced by what? Some source. Some source is must. That voltage source is nothing but voltage across the diode. Okay, good evening, Nikhil. Yes, this is nothing but what when the diode is forward bias in the non-ideal case, the voltage across the diode is to be considered. That voltage is to be taken V suffix D. That is a must only now. If it is a reverse bias, for reverse bias, diode must be open circuited. It is a must. What I wish to say, whenever voltage across diode, when the given supply is what now, supply whenever you gave it now, some drop is possible across the diode. Once the what now, diode starts conducting, then what is going to happen now? It is going to allow the current to pass in the what now, diode only now. That means less than diode voltage if given supply, in that case we cannot find any current through the diode. In case the supply voltage is given greater than or equal to the what now, diode voltage, we can find the what now, increase of the current only now. That current is nothing but ID is going to increase. That's in the reverse bias, we cannot find any current now. The diode current becomes what? 0 only possible. If it is a reverse bias, this is possible, this side. When diode is a forward bias, we are going to find the what now, current is going to increase. Current through the diode is greater than 0 amperes are possible. Try to catch certain points I want to explain here now. You take one diode for example. Practically any diode can have some internal resistance. That resistance we are going to call it as a forward resistance of the diode only now. Any student can say what resistance, what is the range of resistance had by the diode when it is forward bias? This is my question. Any student can give? Any student can give what is the range of forward resistance of the diode when it is forward bias? That's my question. Anybody can give? Anybody can message? What resistance is maintained by the diode when it is forward bias? Anybody? Anybody can give or not? Yes, I can give now. When the diode, practically diode, if it is taken, that can have the forward resistance of diode resistance otherwise 10 ohms to 100 ohms, it is maintained one. Try to understand. When diode is designed, that can have the what now? Forward resistance of range 10 ohms to 100 ohms only. Very practically, we can say one more point. When the design of the what now diode is made, they were not going to maintain up to 100 ohms also. They were going to maintain always less than 50 ohms only. You watch any books in any problems, the forward resistance will be given 20 ohms and 25 ohms, 30 ohms and 40 ohms only. That is not going to cross the what now 50 ohms only now. They are going to maintain that much resistance only. But the range of resistance is acceptable from 10 ohms to 100 ohms only now. Understand my point now. And one more point I want to ask, how many students can give answer at least? When diode is reverse bias, that's my point. When diode is reverse bias, we say in ideal case, it can act as a what now? Open circuit only now. It is acting as a open circuit means it can have some high resistance. What is the range of resistance had by the diode? Anybody can explain? Anybody can say? Okay, good evening all. Anybody can say? When diode is reverse bias, that can have internally some resistance. Reverse bias resistance of the diode. Anybody can say what resistance is maintained by the diode? Very high resistance only. That resistance will be within the range of, when diode is reverse bias, that can have the range 10 mega ohms to 100 mega ohms. 100 mega ohms. That much high resistance had by the what now diode only now. Because of that much high resistance, current passing to the diode is negligible. That's why we are assuming diode is a reverse bias, and then it can act as a open circuit only now. Understand my point now. But anyhow, exactly the VI characteristics of diode can be plotted. Diode characteristics are not linear. It is entirely non-linear only, exactly. By considering linear, we are going to do the what are the problems only in gate papers only now. But exactly how the shape of the VI characteristic curve, we can find that shape will come in this way mostly. Parabolic shape we can find. When diode is forward bias, very practical diode if it is taken. Non-linear characteristics you can find. Such a shape is available. But the point, one more point, students must understand. But in the many textbooks, they will plot in this way. When diode is a forward bias, it is a parabolic shape. When diode is a reverse bias, it is a what now? When diode is a reverse bias, the characteristic curve they will plot like this. I gave the diagram in this way. Is it the right diagram or not right diagram? Anybody can say? Is it correct or incorrect to plot VI characteristics of the diode? Anybody? No, sir. No means what is the reason now? Where we are finding the change? Where we need to change? Manoj Kumar, where we need to change? The shape of the curve we need to change in the forward biasing, or the shape of the curve is to be changed in the reverse biasing? Anybody can say? Anybody can say where we need to change? Yes, this total curve will not be considered. Whenever you are reading any textbook, whenever you are reading the textbook, clearly you try to understand. When diode is forward bias, the shape of the curve is this only, 100% guarantee. It is correct only now. This is correct. When diode is reverse bias, the curve is available up to this extent only. This much portion only, very small portion of the curve, it comes in the reverse bias only now. It won't increase this side, this portion will not come. And students can get one doubt, sir, then why you plotted such a way, sir? Why you are increasing the shape of the curve, sir, now? Clear in the books they will give. From this point to this point, we can find when diode is what? The diode characteristic curve only. Diode characteristic curve is available from this portion to this portion only. This portion of the curve is available whenever the diode is modified as a Zener diode. When diode is modified as a Zener diode, at the time the characteristic curve still extension, it comes like this one, But in this portion, we can find the what now? Zener. Zener only we are going to find only now. Zener characteristics are available this side. Zener characteristics. This portion comes when Zener ordinary diode is modified as a Zener diode only. When it is what now? Only PN junction diode means the shape of the curve is available like this one. This is the portion for reverse biasing, no doubt. That way VI characteristic curve is done. But whenever the nonlinear characteristics curve, by using the nonlinear characteristic curve, if you want to do the problem means the diode current equation is entirely different. That formula will be taken in this way. Diode current equal to I naught into e power voltage across diode divided by eta into Vt minus 1 we are going to put. By using this formula only, what? Calculation of the diode current will be made. When practical diode, if it is taken this way, very practical diode. The ideal and non-ideal means just we are what the now? Linear curve, linear what now curve, it is we are just simplifying into the what now? Linear curve, and we are doing the questions only now. Understand my point now? Anyhow, this the formula is allowed now. If the eta value is 1 for germanium and 2 for silicon, this is a fixed value. And the Vt means thermal equivalent of voltage only now. That is around what now? 26 millivolts. If not given, you can put directly. In some books, but in certain problems, they will give 25 millivolts. Whatever it is given, but generally they are going to put 26 millivolts only now. This is for what? Practical diode now. Understand now? Followed, I hope it now. Anyhow, these are all the just basics of the diode only here now. But we need to watch here now. Where we are finding its application means I said just now. In clipping circuits, clamping, and etc. As I said now. Initially, I selected clipping circuits. Clipping circuits. In the designing of the clipping circuits, we are going to use the diode. This is the first topic of analog circuits I want to take now. Subtopic of the diode only here now. But anybody can define what is the clipping here? Clipping means what? Clipping definition, how we can give? Clipping definition, anybody? The removal of some portion of the input signal is called as a clipping. Some portion of the input signal we are going to truncate, we are going to remove. That is nothing but the clipping only, you can say. So the diode can do the work of clipping in the circuits only here now. Understand my point now. But in the clipping circuit, how many types of the clipping circuits are there generally? There are two types of the clipping circuit. One is said to be diode clipper, second one is said to be voltage limiter. This voltage limiter is entirely different now. That I will discuss later now. Voltage limiter is okay. Okay, voltage limiter also allowed, no problem. Exactly allowed only now. But anyhow, here the exactly what we can say, clipping circuits are two types. One is nothing but the diode clipper, second one is nothing but the transistor clipper. Like the two types of the clipping circuits are there now. But again, diode clipper can be classified as a what now? Series diode clipper and shunt diode clipper. Like that we can divide only, you can say. From the series diode clipper, I will give certain examples now. How we have to get the what now? Output waveform, and also how to draw the transfer characteristic curve that I want to explain here now. Suppose I selected one diode, one type 1 I have taken for example. I selected type 1. In type 1, I have drawn one diode. This is a series diode clipper. This is series diode clipper. I connected to the what now? Load, like this. Load resistance I connected here now. But I would like to take V naught across this resistance only. I am giving input here. That input I want to take it as a VI. That VI I want to take it as a sinusoidal signal only now. Sinusoidal waveform I want to give. Then how the shape of the output is available, that I want to show here now. In case I made an assumption, diode is ideal. I am going to take based upon the diode is ideal, I wish to do the work only now. If diode is ideal, what happens? If VI is greater than 0 voltage, I have taken. Why 0 voltage? We are connecting, we don't have any other supply after the diode. When there is no any other supply, we need to compare with the 0 voltage only. This ground voltage, 0 voltage only. If VI is greater than 0 voltage, what is going to happen? Diode is forward bias. When diode is forward bias, it can be replaced by what? Short circuit only. When diode is replaced by short circuit, what is going to happen? I want to say the diode is replaced by short circuit here now. In that case, same signal will go to the V naught only. That means V naught equal to VI is possible. V naught equal to VI. That means if VI is greater than 0 voltage, diode is on. When diode is on, it is going to conduct. Whenever it is a conducting, V naught equal to VI only possible. In case, catch my point, if VI is other than this means less than 0. What is going to happen now? Less than 0 voltage means the diode will not conduct. The diode can act as a what? Open circuit only, because it is a reverse bias. I can say diode is off. When diode is off, it can act as a open circuit only. In that case, I can draw the diagram in this way. The diode is open circuited. We are having the resistance here. This is the V naught value. Here I am giving the VI. How the shape of the, that means whenever it is an open circuit, it doesn't flow any current. We cannot find any current to pass through the what? No, this diode only. At the time V naught equal to what is possible? 0 voltage only possible. V naught equal to 0 voltage only. That much voltage is possible. Now I wish to draw how the shape of the curve is here available. I am taking the curve. Suppose I am giving input of sinusoidal wave. The Vi is given sine waveform like this. The sine waveform is given as an input one. But I want to draw the shape of the curve, what is available here. This is V naught. What is going to happen? If Vi is greater than 0, V naught equal to Vi. When Vi is greater than 0, this is greater than 0, this is greater than 0, V naught equal to same we can get here now. V naught equal to what I can get? Same waveform available. Same is available. When Vi is less than 0, V naught equal to 0 voltage. When Vi, this is the less than 0 only now. This portion is less than 0 only. If it is less than 0, what we are going to find? We cannot find any conduction. Then 0 only possible. It won't conduct. Again, positive pulse is given. It will try to conduct. Finally, the shape of the output is available. That only you can say. Nagpur Center. I am the GATE Academy studying from the. Yes, very good, very good. Very happy then now. Yes, very happy. So, yes, one student get the now, Manoj Kumar. It can act as a half wave rectifier. Exactly correct. It is going to act as a half wave rectifier only. But suppose the student will say, sir, to draw that diagram, this is the output waveform to plot, is it required this much time? We cannot complete very fast. Yes, it is possible. Very easily we can complete. These questions to watch. How easily we can complete means, suppose I am plotting the diagram. How I will plot the diagram, very easy way you watch. Initially, what the now? This is the initial I have taken Vi, for example. This is Vi I have taken. The Vi is nothing but here I have taken, for example, sinusoidal wave. Directly how to get, I will explain. How the shape I can get. But in this case, you watch, the diode is given, this is the p-type material. This is nothing but n-type material, everybody knows. At this V0, we are collecting from this node. At this node, catch my point, at this node, which polarity is very close from the diode? Positive polarity or negative polarity is very close to the diode only. What are this node only now? From the diode, negative polarity is very close. Negative is very close. Directly we can say, that means a negative pulse is removed. From what point? From 0. Ground is given. From 0 to negative pulse will be removed. That means 0 to, this is the 0 to negative pulse is removed. This total pulse is removed only. That portion is clipped. Directly we can plot how the shape it comes. Yes, we can draw. The positive pulse will conduct. This will be removed. The positive will come directly. Such a way we can draw only. That means without doing any calculation or any mathematical analysis, directly we can draw such a way the shape of the output only you can say. Catching my point now? When the PN junction diode is given, this is a p-type material, it is an n-type material. To this node, you must watch which polarity is very close. Negative is very close to this node. That is nothing but negative. That means which portion is clipped? This is a grounded 0 to negative pulse. 0 to negative pulse clipped only. Rest of shape will come as an output only now. Such a way, in an easy way, we can draw only now. In case we want to draw transfer characteristic curve, how we can draw transfer characteristic curve? You watch. Transfer characteristic curve I want to plot. The transfer characteristic curve means the curve which is drawn from V0 versus Vi. From V0 versus Vi, what is the shape of the curve is available is nothing but we can say transfer characteristic curve only now. How we can get? Already we got the information before. If, already I gave it, if input voltage is, if Vi is greater than 0 voltage, what I said, already given, what I gave it, Vi is greater than 0, V0 equal to Vi, I gave it. V0 equal to Vi, I gave already. If Vi is less than 0 voltage, I gave it, V0 equal to what I gave it already, 0 voltage I gave it. Please watch once. Vi is less than 0, V0 equal to 0 voltage only. Yes, we can write. This is 0 voltage only. By using these two parameters, we can draw the transfer characteristic curve. That's my point. If Vi is greater than 0, what I will get? V0 equal to Vi. V0 equal to Vi means anybody can say how the shape of the curve? How the shape of the curve? Vi is 1 voltage, V0 is a 1 voltage. Vi is a 2 voltage, V0 equal to 2 voltage. Exactly it comes linear like this. It goes such a way only. That shape it comes. If Vi is less than 0 voltage, V0 equal to 0, V0 equal to 0 means it lies on this axis only. It lies on this axis only. Anyhow, the shape of the curve it is available in this way. This is said to be transfer characteristics of the what now? That particular diagram only. For the given what now circuit, how the transfer characteristic you can get means the way we can get now. I will give you one more example, you can understand clearly now still. Suppose I gave it here now. Type 2, one more I will give for example. Type 2. But in this case, I have taken one diode. Ideal diode I connected here now. I connected one resistance and also I connected with one battery. The voltage, this battery voltage I have taken V suffix R, reference voltage I connected here now. I wish to take V0 this side. The input here given is Vi, that is nothing but the sinusoidal waveform is given. Sine wave is given here only now. But I want how the shape of the output is available from this clipping circuit. This is a, how we can draw here now. The VR is given like this. The same, first systematically I will do that now. Then after I will draw directly the diagram also. Directly you can plot the shape of the curve, how it comes. Understand? In case if Vi is greater than 0 voltage, suppose here now. If Vi is greater than 0 voltage, diode is forward bias or reverse bias? Anybody can say? Vi is greater than 0 voltage, diode is forward bias or reverse bias? 100% the diode is forward bias. Whenever diode is a forward bias, it can act as a short circuit. Whenever this is acting as a short circuit, what is going to happen? V0 equal to what? From this point to this point voltage equal to same Vi. V0 equal to Vi only possible. I can write V0 equal to Vi here. V0 and Vi are equal. No drop across the diode. In case if Vi is less than 0 voltage. If Vi is a less than 0 voltage means how the diode can work? The diode can be open circuited only. If the diode is on here in the first case. In the second case, what is going to happen now? Diode is off because it is a reverse bias. Whenever diode is off, what we can do? This can be open circuited only. The diode is open circuited. Here the V0 is taken across what? This particular terminal only. Resistance with a battery we connected here now. This is VR. This is some resistance we got. But a V0 from this point to this point I want. Can you find any current in the network? It is an open circuit. Whenever it is an open circuit, it doesn't flow any current. Whenever it doesn't flow current, what we can say? Voltage drop across that resistance will be 0 only here now. No drop. Finally, V0 equal to what? Anybody can give? What is the V0 here I can get? What V0 I can get from the what now given network when it is a reverse bias? Anybody? What V0 I can get? I can get only what? VR only possible. We can't have any drop here now. V0 equal to only VR we can get. I can write directly. If Vi is less than 0, V0 will be V0 equal to I can take only VR. We can't find any drop across the resistance. The drop becomes 0. Exactly correct, Manoj Kumar. Exactly. There is a V0 equal to VR only. You are giving the VA, I think, This is a V0 is nothing but V0 equal to VR only. This voltage only you will get only now. Understand? Finally, how the shape of the curve will be plotted? You watch. Which portion is clipped, you can understand. This is nothing but Vi. The input Vi is nothing but this sinusoidal waveform I have taken like this. For example, I selected such a way. The VR is given, VR is a positive, this is a plus and minus, positive potential only. I can take this potential is VR. This is nothing but V suffix R. I can write now, V suffix R. But how we can draw the shape of the output? Vi is greater than 0, V0 equal to what is V0 equal to 0 we can't take because the VR is existing. When VR is existing, this potential must be changed. This potential, just I will change, please wait. Please wait here now. Zero not acceptable. Where 0 I can take? If it is not having any source, any voltage we are not having means we will compare only now. If the source whenever given, we need to change now. I'll change, please watch. I say here, but a Vi is what? Greater than VR only possible here now. We can't take 0, VR is existing. When if Vi is greater than VR, then diode is on. When diode is on, V0 equal to Vi only. If Vi is less than what value? Less than VR, because VR is existing. Because I didn't watch that VR. VR is existing. Then diode is off, V0 equal to VR is possible. Then we need to understand if Vi is greater than VR means this portion is greater than VR. This portion is greater than VR only. If it is greater than VR, what is going to happen now? V0 equal to Vi. V0 equal to Vi only. V0 equal to Vi means I can get this portion. This portion will come as it is. Greater means same shape of the curve is available. If it is greater than VR means V0 equal to Vi. I will get the same shape. This curve is available. When Vi is less than VR, less than means this portion is less than VR. This portion is less than VR. This portion is less than VR. Less than VR means V naught equal to VR. V naught equal to VR means this portion I can get. Finally, the shape of the output will come such a shape. Once asked on the gate, this question also then. Thank you, Vipin sir. Here we got the output in this way only now. This way we can draw only now. Understand now. But now here, without doing this calculation, directly I want the shape of this curve, sir. Can you plot it? Yes, we can see now. How to plot, please watch. I will draw here now. How we can draw means, this is nothing but the Vi. This is the sinusoidal waveform given like this. Input we are giving the shape of the curve like this now. That's my point. This is nothing but the VR, V suffix R. But I want to draw the diagram directly. How I will draw, please watch. This is nothing but the V naught I want to draw directly. But at this node, we need to watch what polarity is very close. Is it a positive or negative polarity is very close? It is a P-type material. It is an N-type. N-type means negative polarity is very close. Negative only very close. Which portion is to be clipped? We are not 0 here now. 0 to negative I cannot take here now. In before that we got what now? One more voltage also. VR to V naught. VR to negative pulse will be removed only now. VR to negative pulse. VR to negative pulse means VR is starting from here. That's my point. VR is starting from here. This portion is VR to what portion? Negative pulse. Negative pulse means this total pulse will be removed only now. To the negative pulse, this is removed. And finally, what is the shape I can get here now? This shape I can get directly. Only this portion will come. That means VR to negative pulse. VR to negative, total negative only now. So finally, we are getting the shape of the curve in this way. Directly, the shape of the output we can plot only now. Such a way we can draw the diagram without doing any work, without doing very work, directly we can plot only now. But how we can draw the characteristic curves, a transfer characteristic curve? I will give, please watch. How to plot the transfer characteristic curve, I will give. But I want to plot the transfer characteristic curve. Characteristic curve. I wish to plot. How to plot this is very important now. But already you got what I gave condition. If Vi is greater than VR, I gave already I gave the conditions. What are the conditions I gave it? If Vi is greater than VR, V naught equal to Vi. We got already. V naught equal to Vi. We got already. Second condition I gave it already. What I gave it? If Vi is less than VR, V naught equal to VR. If Vi is less than VR, we got V naught equal to what? VR only. Now we can draw the transfer characteristics. How I can draw? Please watch. The curve which is drawn from the V naught versus Vi is nothing but transfer characteristic curve. In this case, if Vi is greater than VR, VR is some positive potential. Somewhere we can put Vi is greater than VR. This is VR I selected for example. Greater than VR means V naught equal to Vi. Less than means what? Less than VR means V naught equal to VR. V naught equal to VR means parallel to the x-axis only. If V naught equal to VR, this voltage is VR value. Less than VR means V naught equal to VR. If it is Vi is greater than VR means V naught equal to Vi. V naught equal to Vi means the shape of the curve is available such a way only now. This is going to be what? Transfer characteristic of the given circuit only now. That way we can draw the characteristic curve only, you can say. Just one more example I will go, then after I will enter into the next model circuits only now. Understand now. Just one more, understanding purpose. Suppose I am giving here now. But I want the output curve for the given circuit diagram. I selected one ideal diode. I connected this with a resistance, and also polarity of the battery I selected in this way. This is VR. Here I want to get the V0. From this clipping circuit, I want to get the shape of the output, how it comes, I want. The input voltage here given is nothing but Vi. I made an assumption given Vi is nothing but the sinusoidal waveform. If it is a sinusoidal waveform, how the shape of the output is available, that I want. How we can draw this? Now please, initially I will do systematically. Next, directly I will plot this diagram now. Please watch. I can write, we need to compare this Vi. If Vi is greater than this voltage, diode is on. If Vi is less than this voltage, diode will come to what now? Off state only. The same condition I want to apply here now. If Vi is greater than what voltage? This is with minus Vr, I can take it now. Greater than minus Vr, you think it's so. Immediately what is going to happen? Diode can act as a what now? Short circuit only. It is going to conduct. The diode is here forward bias. Once the diode is forward bias, what is going to happen? Diode is on here now. When the diode is on, what I can get? What V0 I can get? This can act as a short circuit. V0 equal to what now? Same voltage I can get. V0 equal to Vi only. V0 equal to Vi. I can put direct. In case if Vi is less than minus Vr, I have taken now. This input voltage is less than minus Vr. In that case, diode is a reverse bias. Once the diode is a reverse bias, we cannot find conduction of diode only now. The diode can act as an open circuit. I can draw a diagram in this way. This is open circuit. Here we are going to get the V0. The resistance I got with this battery, with VR. Now finally, anybody can say what V0 you can get here now? Whenever this circuit is open, we cannot find any current in the network only now. V0 equal to only minus VR you will get now. V0 equal to what? Minus VR we can get now. Minus VR. And finally, the shape of the output from this clipping circuit will be plotted in this way. This is Vi. The shape of Vi is given in this way. Sinusoidal wave is given such a shape, input. And here this is nothing but minus Vr. This voltage is given minus Vr. I will put this is minus Vr here given. This is minus Vr. But I want V0 from here now. From this clipping circuit, how the shape of the curve we can get. That is very important. What shape I can get? But this is the negative only now. This is the negative, minus Vr, this value. This is minus Vr. If Vi is greater than minus Vr means this portion will come greater than minus Vr. This portion is greater than minus Vr, I can say. This portion is greater than minus Vr. This point to this point is greater than minus Vr. That is why V0 equal to what? If Vi is greater than minus Vr, V0 equal to Vi. V0 equal to Vi means same shape I can get directly. If it is greater means same shape I can get here also. Greater than minus Vr means same shape I can get. If Vi is less than minus Vr, this portion is less than minus Vr. In that case, what is going to happen? V0 equal to minus Vr. This portion is minus Vr. Finally, the shape of the output which I can get from the given clipping circuit is this only now. Understand? Anyhow, these two shapes are same, equal shapes only we can find. Understand? But in case the students are willing to draw the what? This output waveform directly, you think it's so. How we can draw? Please watch. I will give the note. If you want to plot very directly, we can draw. Directly I will give. This is Vi. Here given the input of sine. Input of sine waveform is given. Here given minus Vr. Yes, I will put this is the minus Vr. This is nothing but minus VR here I have taken now. And I want to get output here now. I want to get output V naught only. How we can draw? We need to watch which polarity is very close at this node. Is it a positive polarity or negative polarity is very close to the what now that node? We can take the negative only now. Negative polarity is very close. The clipping is done from where? Minus VR to what? Negative pulse only. Minus VR2. This is the minus VR2. Which portion? Negative pulse. This is the negative pulse up to this extent. This portion is removed. Minus VR2, negative pulse only. That's why that portion is removed means what I can get here now? The shape I can get in this way. That shape I can get on now. This is nothing but minus VR I can say now. That way directly we can plot the shape of the output from the what now given clipping circuit only. I think the students followed what is the way to plot. Just like a last question, you can draw the transfer curve only now. Followed or not followed? Anybody has got any doubt? Anybody has got any doubt? Anybody? Any doubts regarding? Sir, yes, very good. Now, the Ravi said yes, sir. Okay, then very good. Now we can see this is the way we can do the what now clipping circuits only now. Understand now? That way we can do the questions from the clipping circuit only now. The next one I want to take how the clamping circuit will be there now. I explained in the clipping circuit how the shape of the waveform it is generated. I explained here now. Produced only right now. Now we can take the clamping circuit. Clamping circuits. In the GATE exam, you can expect the questions from the clamping also. Very easily you can score from the clamping. It is not required any effort or the more also. Now, how I will do this you watch. How easily I will do the questions from the clamping you watch. But anybody can say the definition of clamping circuit, clamping definition. How you can define clamping. The shifting of the what now? Input signal to the some reference level only. Some reference level means that may be shifted to the what now? Positive side. Otherwise, it may be shifted to the what now? Negative side also. Any one of the side we can shift only, you can say. But how many types of the clamping circuits are there? Means there are two types of the clamping circuit. One is said to be what? Positive clamping. Second one is said to be negative clamping only here now. But here DC level shifter, very good. There is a DC level shifter. Because why we are saying DC level shifter? We are shifting to the what now? Positive side. Otherwise, we are shifting to the negative side only. We can't find, once if it is shifted to the positive side, we can't find any shape of the waveform in the what now? Negative side only. Whenever it is shifted to the negative side, we can't find any one of the waveform on the what now? Positive side only. That's why it is said to be DC level shifter also 100%. Yes, Manoj Kumar, you are perfectly now. But anyhow, the clamping circuits, how designed? What are the components are required to design the clamping circuit? Anybody? What are those elements are needed to design any clamping circuit? What is required means we need to have the capacitor and also we need to have the what now? Diode and also must one resistance only. Diode, resistor and also what? Diode, resistor and also what is required? Capacitor is very important now. But all the gate papers are given only with the diodes and capacitors only. He will not include the what now? Capacitor only. Whenever capacitor will be included, no diode will be connected, no resistance will not be connected in all the gate questions only. When the resistance is connected, you think it's so. The problem is the length only now. It becomes 1.5 ways only now. It takes a time of the more only now. That's why without the use of the what now? Resistor only, we are going to do the problems based upon the clamping circuit only here now. Understand? Just you listen how I will do this question here now. In the clamping circuits, I said negative clamping and positive clamping, two types are there. I said now. Suppose I selected one capacitor like this. There is a capacitor. And I connected one diode. I selected one ideal diode here now, for example. I connected one diode like this. Here I am giving the input of sinusoidal waveform. Sine waveform is given like this. I wish to get the what now? V naught across this only now. V naught I want to get from here now. This is the capacitor. But I want the shape of the output, how it comes. Suppose a VI I selected in this way. This waveform I am giving here now. I am giving the what now? Positive pulse initially. Next it goes negative pulse, positive, negative. It goes like this only totally. Finally it goes such a way only. How the shape of the curve we can get here now? How the circuit, how the output waveform we can generate. This is the V naught I want to get. How we can get V naught here is required. How we can get means, but I am not giving the what a full explanation. Very directly I will plot because students can understand how we can draw. How the diode connection is made here now, please watch. How it is given the diode. Diode is connected to the what now? This side. It is going down only. It is down. Whenever it is a down here now, what you must do, the curve will go to the down totally. It is shifted to down totally only. This waveform will be shifted to down only now. If it is shifted to the down means how the shape is available. That means this the peak point will, the peak level will touch exactly what origin only here now. Whenever it touches the origin, the shape will come like this only now. The output waveform I can get in this way. Such a shape is available. This will be shifted to down. Directly this is said to be negative clamping only. Directly we can say negative clamping only. In case I am giving clearly you watch. I am connecting one capacitor for example. I connected one diode here now. One source in the gate this problem. This is the V naught I want to take here now. I am giving the VI, one gate question I am giving here now. The waveform here given is in this way. The shape of the output is dash. Options are given for options now. Anybody can say how the shape of the waveform it comes? Please watch. The connection is given. The diode is connected to down. If it is connected to the down, that will be shifted to the down only directly now. I can draw a diagram in this way. Directly we can plot. This is VI. The VI is given here now, negative and positive only. That shape is given now. And here I want to get the V naught. What now? One more V naught I want it. Otherwise, I will draw in the next page best you can understand clearly. I will plot, just watch. The next page I will draw clearly now. I am giving once again. There is a capacitor here. Sorry. I connected one capacitor here. This is connected with a diode. One source in the gate for 1 mark, very long time before. This is V naught. Here I am giving the input VI. The shape of the curve I want to give in this way. How the shape of the output we can get if it is given? It is shifted to down. Ravi says it is shifted to down. Very perfect only now. How it is shifted here now? Please watch. If I gave input in this way, if I give input in this way, the shape of the output directly you can identify. When the 4 options are given, this option you can select. That will be shifted to the down. That will be shifted to the down means that the peak value must touch the what now? Origin only now. That means I can draw, it will go this side. This will come to this side. This will come to this side. How I can draw this? This shape will go. Clear level. Just wait, I will clear. I am giving here now, this must go to down only now. If it goes to down, how it comes? The shape will come like this only now. That shape will come like this only now. It will go down and will go to what now? This will go to down and will go to top and finally it comes to this side. Anyhow, the shape will come this side only. That shape it comes clearly. That way the shape we can get only. That will go down only directly. In case one more diagram I will give, clearly you can understand. If you are given the what now one capacitance of the capacitor like this, a diode is connected to top. I'm asking how the shape of the output I can get if Vi is given this waveform. If I give such a way, the Vi is given here now. Can you plot output for this? We can draw in this way. How it is shifted? It will be shifted to the downward or topward. In which direction it will be shifted now? Down or top? We shifted to the top only now. Directly it is shifted to this side. If it is shifted what now, this point must reach to the what now? Origin only now. I can draw a diagram like this. This portion will touch like this now. This will go this side and will be moving to this side only. Sorry, this will go on this side. I will clearly draw. This is right. The shape how we can draw. This will go to top only. Whenever it goes to top, we can draw like this one shape. That shape I can get only. That is the shape of the output we can get from the what now? Given problem only. Upward, very good. Yes, exactly correct. Yes, positive clamper. Exactly, it is a positive clamper. So I hope the students followed how the shape of the waveform will be plotted if it is given any clamping circuit. Sometimes in the gate questions, how they were asked is asking the steady state voltage across the capacitor only. How to find that steady state voltage across the capacitor, I will explain very easily. I will do those questions also now. Understand? Sometimes what happens, asking questions like this. Find steady state voltage, steady state voltage across C2, across C2, capacitor C2 only, across capacitor C2. Diode is ideal here now. Here given, first capacitor is given this and connected with one diode in this direction. And here connected with one more capacitance of the capacitor this side. Here connected with one more diode this side. One more diode is connected this side only. Is asking voltage across this C2 only now. Steady state voltage across C2 is asking to find. Here connected with source Vi only now. Vi is connected here now. That Vi is given sinusoidal wave. This is Vi. It's given sinusoidal waveform. That voltage is given, this is the Vm is given here. This voltage is given minus Vm only. Plus Vm and minus Vm is given. Two diodes are connected and is asking to find the steady state voltage across the C2 only now. How we can find steady state voltage across the C2? This type of questions asking in the gate. You watch how easily you can complete. First I will do systematically. Then after I will explain what now direct method, how to find out the voltage across C2 only here now. Initially what we have to do, we need to give the positive pulse. When you are giving the positive pulse, please watch. I am giving here positive pulse plus minus. That voltage maximum Vi is the Vi equal to what I am giving? Maximum voltage only. This is Vi. I am giving. For example, Vm equal to understanding purpose I am giving. For example, 5 volts for example, I gave it for example. This is the minus 5 voltage for example, I gave it clearly, you can understand. Now I am giving here Vi equal to how much here now? 5 voltage I am giving, positive pulse only. In that case, which diode is on and which diode is off? Anybody can say? Which diode is on and which diode is off from the given circuit? Both are ideal diodes only now. Which diode is on and which diode is off? In this case, anybody? Anybody can react? Which diode is on and which diode is off? Anybody? In this case, we can find diode D1 is a forward bias only. Positive is connected to the positive only now. Positive is connected to the negative only now. D2 is a reverse bias. D1 is on, very good. The Gopi gave the D2 is off, very good only now. Now we can say in this case, D1 is on. When D1 is on, it can be replaced by short circuit. It can be replaced by short circuit only. And second diode is a reverse bias. Whenever it is a reverse bias, it can act as an open circuit that can be removed totally. How the polarity will be taken here now? When the Vi is given, that polarity initially, whenever the positive pulse you give it now, the positive polarity you get now. Plus means same plus. Because of the induction, this side we can get the negative polarity only now. Whenever you are applying the KVL, you will get the voltage across this capacitor. One VC1 we can find. What voltage we can find here now? Same 5 voltage only now. So VC1 equal to, I can put 5 voltage here now. VC1 is nothing but 5 voltage we are going to get. That is the maximum voltage you will get only now. In case, please watch, in case we are giving the negative pulse now. During the positive pulse, I got this. During positive pulse, I got this. In case you are applying the negative pulse, during negative pulse, when the negative pulse is given, what is going to happen we can see. In this case, D1 is off because it is a reverse bias, and D2 is a forward bias. 100% it is on state only when the negative pulse is given. I can select this polarity minus and plus. We are giving the negative pulse only now. That voltage is given as a what now? 5 voltage. What 5? Minus 5 only here now. But in this case, this capacitor is a what now? Charged. That is with some steady state voltage. What amount of the voltage? 5 voltage only. That voltage will not be changed. Whatever the voltage comes across this C1 will stay there only now. This voltage is nothing but the 5 voltage we got already. And this diode is a open circuit. It is a reverse bias. I can remove that. It is open circuited only here now. Second diode is forward bias. When it is a forward bias, I can short circuit. There I can connect with a what now? Capacitor C2 only now. Now I wish to find voltage across this C2 only now. That voltage I want to take it as a VC2 only now. How we can give the polarity here now? Here we got the positive polarity. Same polarity will come to this plate. Because of the induction there we can find the negative polarity only now. We need to find VC2. What VC2 it comes by applying the KVL directly we can get now. How I can apply the KVL in this direction? I can proceed. If I move that direction, I can find the VC2. When I move this side, when I go from here onwards, minus 5, I'm going this side, minus 5. When I come this side, plus VC2, KVL I apply. When I go this side, minus 5, that equal to 0 only. Finally, what VC2 I can get from this network, from this equation? VC2 is nothing but 10 voltage I can get only here now. Like that, what you can say, the voltage across C2 will be calculated only now. Sir, I cannot do this much work. Directly, I want answer for this question only. What way I can do, sir? Yes, I will explain now. Initially, I explained how the what now operation will be done, how the what now voltage is to be calculated systematically. I have done now. Now directly what now how to get VC2 without using the what now any calculation. Yes, you watch here now. So far followed or not followed? Students, followed or not followed up to this extent? Anybody, if you are giving the reply means immediately I will be motivated more only still. Understand? Yes, please watch, I will give. I said directly if you want to get means how, please watch. I gave the problem in this way. There is a capacitor C1 I gave and I connected one diode here. One diode I connected and also 10 voltage, very good Gopi, 10 voltage only. I connected here and here I connected one more capacitor C2. Here I want to connect one more diode. That way I connected one. But I wish to find voltage across C2. Here I connected with input. What input I gave it? Sinusoidal wave. Sorry, sinusoidal wave is given, no doubt. This is nothing but plus 5 voltage I gave it. Or by Vm. This is nothing but minus Vm I can get here. Minus 5 voltage I can get. But directly we can get what way means, please watch. Whenever any number of capacitors, any number of diodes are given, it doesn't matter now. Methodology is same. Initially, polarity is to be given to the what? No, capacitors only. How the polarity is to be given? You go from this side, plus, minus. You go this side, plus, minus. If you got any other capacitor, plus, minus, it goes only. Initial capacitor can have the maximum voltage of Vm, 100% for any circuit in the clamping. Initially Vm only. The second capacitor can have 2 Vm directly. 2 Vm you can get only now. The Vm and 2 Vm you will get only now. When you want to find the voltage across C2, directly you can write 2 Vm. What is the maximum voltage here given? 5 voltage only. 2 into 5, 10 over. No KVL, nothing. Directly we are getting the 10 voltage only, you can say. Such a way we can get the what now? Voltage across the C2. That is the steady state voltage we can get only now. Suppose if it is given more than these two, sir, how we can do? Just I will explain, please. One more question I will give, you can understand clearly. Suppose you are asked, find steady state voltage. Voltage across C4 it is given, for example. C4 up to C4. Now you need to give answer without my help. Here connected with C1. Asking in the gate this type questions, repeatedly asking. There is a diode D1 here. And I connected with what now? One more capacitor C2 here. And also I connected with one more diode this side. This is D2 I have taken now. And here I connected with one more capacitor C3. And I connected diode D3 this side. I connected one more D3 this side. And I connected one more capacitor this side, D3. This is a C4. And I connected with one more diode this side. All these are ideal diodes only. I am asking voltage across this C4 only, steady state voltage across C4. Anybody can give answer immediately? Without my help, you tell me. Here I am giving the input voltage Vi here. Here given with Vi. Suppose that Vi I want to give in this way. This Vi is nothing but sinusoidal waveform I am giving this side. This is nothing but maximum voltage is nothing but 5 voltage I have taken, for example. The maximum voltage minus 5 voltage here I can get now. Anybody can say what is the steady state voltage across C4? Anybody can give answer? 20 voltage is giving, Gopi is giving 20 voltage only. Yes, that is not allowed. 20 voltage is not allowed across the capacitor. But you say, but a voltage across C4 is a 20 voltage means what happens now? It is more than the given input only. Given input, what now? Given input is what now? Peak to peak, how much voltage you can get? Peak to peak, what voltage at the input side? Vm minus Vm, 2 Vm you will get now. Input of the circuit is always 2 Vm only, here you got. But the 2 Vm you got means more than 2 Vm you cannot get across the capacitor. Voltage across the capacitor, you cannot get more than the what now? 2 Vm only here now. I say initial capacitor, but initially how the polarity will be taken now? When the supply is given, that polarity will be plus minus, this side plus and minus. When you go this side plus and minus, when you go this side plus and minus, you will get now. How the voltage, steady state voltage across the capacitor, initially that can have Vm. The next one is nothing but the 2 Vm, no doubt. Next one, we cannot take 3 Vm. 3 Vm, if you have taken means what? The diode is acting as a what? Amplifier only. It doesn't act as an amplifier now. More than the input voltage never comes. That's why this will give maximum of 2 Vm only. Next one also same 2 Vm it can give. Even you have taken the one more, it can give the what? 2 Vm only. Yeah, but the totally I got the capacitors up to N. N, first one is a Vm, the rest of N minus 1 with what voltage? 2 Vm only possible now. So voltage across C4 if you want to find, voltage across C4 if you want to find, directly we can write 2 Vm, directly we can write. Vm is nothing but how much? 5 if it is given, 2 into 5. Directly I can write as a what not? 10 voltage only, I can get only guess. That way the calculation of voltage will be done only here. Forward or not forward. Suppose you are asked, can you find what voltage I can get from here to here now? Suppose I asked, what is the voltage here I can get from this point to this point? Suppose I ask, sometimes asking in the gate, what voltage we can get from the output is taken from these two terminals. The output is taken across these two terminals. Anybody can say what voltage we can get? Anybody can say? This is nothing but V01 I have taken for example. Anybody can say what V01 I can get? What V01 I can get if I selected output across these two terminals? Anybody? Anybody can say what V01 we can get from this network? Can you please watch? This is nothing but the VM. When you go, KVL is applicable from this point to this side, this point only. When you are moving from this point to this point, plus VM, plus 2 VM, totally how much? 3 VM I can get. V01 is nothing but, when you go this side, I am getting the plus VM. When I go to the front, I will get the plus 2 VM again. Plus 2 VM I can get. Finally, what voltage we can get here now? 2. Sorry. Just wait. Just a minute, I will do. I say this V01, how I can get here now? If I want to get the V01, when I go this side, plus VM I can get here now. When I go still front, plus 2 VM I can get here now. The finally VM plus VM, what is you will get? 3 VM I can get now. 3 into 5, it becomes a 15 voltage I can say. Catch my point. Voltage across each capacitor will not exceed 2 VM. The voltage what now? Voltage between the two terminals will be more than 2 VM also possible. More than 2 VM is possible between the 2 points. Between these 2 points, if it is taken, their possibility is what not? 3 VM also possible only. 100% perfect, Gopi. That way we can do, Follow this. Anyhow, from the clamping circuits, the work will be done in this way only. I think the students could understand this methodology only. Understand. Next one, we can go to next model now. So I did the clipping and clamping. But how this what now? First what now? Clipping and clamping, mostly we are expecting the what now questions only now. Next one we can enter into BJT best now. Biasing of the transistor is best. I want to take biasing of transistor. How we can do problems from what now questions? The biasing of transistor, you can understand. Biasing of transistor. Biasing of transistor means first initially you need to understand why the transistor is required. What purpose we are going to use the transistor? The transistor is used as an amplifier only. But once in the what now, one of the competitive exam, once the what now, whenever the student is getting this success, he got the interview only now. In the interview, one question was asked only now. The student only said it to me, The which type of transistor we are using practically? The question was asked in the interview like this only. Which type of transistor is used practically? Which type of transistor we are using? The question is NPN or PNP, he asked. Which type of transistor used practically? Anybody? Which type of transistor is used practically? PNP or NPN? Anybody? Which type of transistor? Yes, Ravi says NPN only now. But immediately what now? In the interview, those people said no, you are wrong only now. But the question you have to understand, switch and another amplifier, switch and another amplifier. No, I am asking which type of transistor is used practically only now. Practically using both only now. The question you have to understand, what is so asked? I didn't ask which type of transistor is mostly useful. I didn't ask. Which transistor is used in practical application? Both we are using. PNP and NPN transistors, both we are using only now. There's an answer it is to be given. PNP and NPN transistors are used. The next question in the interview was asked like this only. The student only said now. But out of these two, where we are going to use, for what purpose we are going to use PNP? For what purpose PNP we are going to use now? That means because of the PNP transistor, when you can use PNP, that is the main question. When you can use PNP, when you can use NPN, that is my question. When you can use NPN, when you can use PNP transistor in practical application. Anybody? Whenever output current of the more is required, you think it's so. Generally in practical applications, it is used NPN transistor. Majority carriers are electrons. Electrons to move, potential required less, it comes more current only now. Wherever you want to get the what now output current of the less you think it's so, at the time you need to use the PNP transistor only. That is the answer. Wherever you want to get the output current of the more, you need to use the NPN transistor. Wherever output current of the less is required, you need to use the what now? PNP transistor only now. Understand now? But why this the transistor, whenever it is taken here now, what are the configurations of the transistors are mostly possible? There are 3 configurations we know, because based upon the configurations, sometimes asking questions in the gate. That's why. What are the 3 configurations we are using? Common base configuration, common emitter configuration, common collector configuration we are using. For example, I selected here common base configuration. For example, I selected common base configuration. I selected common base configuration here. If you selected common base configuration, how we can draw the diagram for this? Common base means we can draw like this. We can draw like this circuit only. Input is given here. We are going to give input here now. Output is received from this only. We are going to receive the output. Understand now? Common base. We are going to get into the emitter is given like this only now. Understand now? And in this case, just clear I'll give. Just wait once. Just wait once. Just with a structure I will give clearly, you can understand. With structure I want to plot, for example. With structure, just I am putting now. PNP or NPN, anyone you can take, for example. This is the structure of the transistor. Base is grounded. I am giving input this side. But I want to receive output across these 2 terminals. This configuration we can call it as a common base configuration. That's my point. Good concept you will get. Understand now. But when the input is given, this side it is going to flow current of what? IE. This current we are going to call base current. This current is nothing but emitter, what collector current we can say. Collector current is going to flow only. Now my question is here now. Yes, in common base, high output impedance, high output impedance. Yes, we can check the now, understand now. But this is the common base configuration. My questions you ask now, one by one I will ask. Clearly, you try to catch my point. In the common base configuration, why we need to use the common base configuration? But once asked, sometimes asking, the purpose of the common base configuration is dash and dash, dash and dash. Voltage gain more, current gain more, first option. Voltage gain less, current gain is a less. Third one, voltage gain more, current gain is a less. Current gain is a more, voltage gain is a less. Like that 4 options anyhow given. So anybody can say for which purpose we need to design common base configuration in practical application. What purpose? For what purpose we need to use common base configuration? That's my question. Voltage gain you want to get more, current gain you want to get more, both are required more, both are required less, or any one is required less. That's my question. Anybody? Can you react to give answer for this? Anybody? Yes, I will give clearly now. Whenever you want to get voltage gain is required more SAR, current gain is required less SAR, you must select common base configuration only. That is the main purpose of the common base configuration. When you want to get the voltage gain of the more, current gain of the less when you want to get, you need to use the common base configuration. That's you can understand the points here now clearly. That is the first point you need to understand. But what about the power gain? Anybody can say? The power gain we can get from the common base configuration is a more or less. Chances to ask one more question only now. Anybody can say? Power gain from the common base configuration is less, more, moderate, none. Which option is correct? Anybody? Same. Same means I don't understand. Same means what? Voltage power gain is a more or less or moderate or none. I am asking question. Which is right? Anybody? Directly you can write. Power gain is less. power gain from the common base configuration is less only, we can say. But a voltage gain into current gain equal to power gain only. Voltage gain is a more into current gain is a less, more into less equal to less only available. Any one is a less, you will get less only. Voltage gain is a more, current gain is a more, power gain also more only. Voltage gain is a less, current gain is a more. One is a high and one low means power gain is a less only available. Any one is a less or both are less, you will get the less only. One is both are what now? High means we can get the more only here now. Understand? Anyhow, power gain available from the what now common base configuration is a what now less only possible. I'm asking the one more question. Sometimes chances are there one more question. You will get input impedance of the more or less, output impedance of more or less, you will get from the common base configuration. How the input and output impedances will be maintained in common base configuration. Anybody can react? Input impedance is required more or less from the common base configuration. You need to maintain input impedance or input resistance is always low possible. Output impedance is maintained high. This is must. That is must only. In common base configuration, input resistance is a low and output resistance is a high only possible now. That way they are going to maintain. Understand now? Sir, why it is the output resistance is a high? Due to what reason we are going to maintain high resistance output? You need to understand. When we can get the voltage gain or the more from the amplifier in common base amplifier, you need to watch. But whenever the output resistance is high here now, when the output resistance is high here, what is going to happen? A drop across this output resistance will be more possible or less possible. When resistance is high, voltage drop also more possible. When voltage drop across, the resistance is a more, they will say voltage gain available from the circuit is a more only. When drop across the R0 is a more, they will say voltage gain available from the circuit is a more only now. In case output resistance is a low, you think it's so. Voltage drop is a less, they will say voltage gain available from the what now, given network is a low only, they will say only now. Now the point in this case was, when output resistance is a high, current passing through the R0 will be more possible or less possible? Think it. Current passing through the R0 will be more possible or less possible? Less only possible. As current through the R0 is available less, then current gain also available less, they will say. Because of the output resistance high, voltage drop high, then voltage gain also available more. When the resistance is high, current across the R0 will be low, and what now current gain also comes low only, we can say. Those points are very important. Understand now. These are all the cases are required from the common base configuration. And one more point also very important. Sometimes they may ask, can you say the current gain from the what now? This common base configuration. The what now current gain of the common base configuration is given a symbol of alpha only. Alpha means output current by input current. IC by IE. The quality of transistor is calculated by alpha value. If alpha value is maintained more and more, the quality is very good. Alpha value is decreasing now, quality of the transistor is less. Now can you say the range of alpha maintained in practical application is dash to dash? Anybody can give answer? What range of alpha is maintained in common base configuration? Anybody? In common base configuration, the range of alpha is maintained from one point to the other point. Anybody can give that range? Anybody knows or not? What is the range of alpha possible? Anybody can react? Yes, it is correct. IC by what now? IC by IE is nothing but the current gain, no doubt. I am asking the range of alpha is what? The range of alpha is dash to dash. What is that value? I am asking. That's my question. What is the range of alpha? Yes, it is maintained. Alpha value will be maintained 0.95 to 0.998. That is the range of alpha is maintained practically. 0.95 to 0.998. That is the range of alpha is maintained. Suppose in the designing, if anybody said in the what now interviews, sir, I can design common base configuration with alpha is what now 0.9 star. and immediately they will laugh. You get out from this place. If you are designing any common base configuration less than 0.95 means it is a meaningless. Minimum alpha we are in need of 0.951. Suppose anybody said, I can design common base configuration with alpha equal to 0.99999 star, immediately we will get a heart attack only now. Impossible. Nobody can design. So far, nobody designed with alpha of what? 0.999. Maximum, what now? Value of alpha designed with 0.998 only now. If anybody designed, they will get a Nobel Prize also, 100%. Understand now. That way it is possible. Anyhow, the range of alpha is 0.95 to 0.998 is possible. These are the information regarding the common base configuration now. The next configuration is common emitter configuration. Common emitter configuration. Common emitter configuration. But this is the, suppose with a what now same structure I am drawing here now. This is the PNP transistor, for example. The input, this is nothing but the emitter. This is nothing but the collector. The output I want to receive across these two terminals. But the input is given in between these 2 points. I am giving the input in between these points. This current I want to take it as a IB. This current is to be taken as IC. This side reverse it comes. IC. This side is a reverse only. This is IC. This current is taken IE1. IE equal to IB plus IC required. This is common emitter configuration. But from the common emitter configuration, just I want to ask certain questions. How many students can give? You can expect 1 mark questions also theoretically like this now. The purpose of the common emitter configuration is dash and dash. Voltage gain more, current gain more. Voltage gain moderate, current gain is a moderate. Voltage gain is a less, current gain is a less, none, which is right. Anybody can see? What is the purpose of common emitter configuration? Anybody can give answer? Anybody can give answer? What gain you want to get more? In this case, we can say point number 1. Whenever you want to get the voltage gain you want to get the moderate, not more, moderate. And current gain, I want to get the what now, moderate. Both are moderate is required. Then you must use common emitter configuration. But mostly in many textbooks, they will give wherever you want to get the high voltage gain and high current gain, common emitter is used. No, high is not acceptable at any cost. Moderate only you have to give, understand now. Average, very good. Moderate voltage gain and moderate current gain, whenever you want to get, you need to use the what now, common emitter configuration only. I am asking the question, voltage gain you can get from the common base configuration is more or common emitter configuration is more? Anybody can react? The voltage gain we can get from the common base and common emitter means which is where we can find more? Where we can get more voltage gain? Common emitter or common base? I am asking question. Voltage gain we can get from common base or common emitter more? Anybody? You must react. You must respond. Anybody can respond? They are only given, very starting itself, so I gave it now. What is the purpose of the common base? Voltage gain more I specify. But in the common emitter configuration, I didn't give more, moderate only I gave it now. Now you tell me moderate is greater than more or more is greater than what now, moderate? More is greater than moderate only now. At the time we can say voltage gain, what now, from the common base configuration is always more only possible. Current gain you can get from the common base configuration is more or common emitter configuration is more, I asked. Anybody can give answer? Where we can get the what now, current gain of the more? Is it in the common base or common emitter? Anybody can respond? Anybody can respond? Where we can get more current gain? Is it from the common base or common emitter? Anybody? You can understand. In the common base configuration, I gave it current gain is what? More or less I gave it. Less only I gave it. In common emitter, clearly given, it is a moderate. Moderate is always greater than what now? Less only now. At the time, current gain we can get from the common emitter configuration is always more only, we can say. Understand now? Current gain from the common emitter is more. Voltage gain we can get more from the what now? Common base configuration only, we can say. Understand my point now? What about the power gain? Anybody can say the power gain from the what now? Common emitter is a more or less or moderate? Anybody? More or less or moderate? The product of voltage gain and current gain can give the what now? Power gain only. Moderate voltage gain into moderate current gain, I can get moderate power gain only now. I can say power gain is moderate here. Power gain is moderate, I can get. This also moderate. Now I am asking the question now. The power gain we can get from the common base configuration is more, or power gain we can get from the what now? Common emitter configuration is more. Anybody? Which is where you can get more? Power gain from where you can get more? Common emitter only. In common emitter, power gain is a moderate. There we are getting. In common base, power gain is what now? Less only available. Then we can say the power gain from the what now? Common emitter is always high only, we can say. But what about the input and output impedances now? Both are what now? Moderate only. They will maintain. Input impedance is moderate, they will maintain. And output impedance is moderate. Output impedance is moderate. Both are moderate. Impedance is moderate. Both are maintained moderate only. Moderate. I said already, but a moderate voltage gain you want to get means moderate voltage drop is required from the resistor, output resistance only. That is why output resistance is a moderate. Understand now? Current gain also what now? Moderate means what now? Moderate output resistance can give the moderate current also. Now, understand now? That is why these points are very important. So current gain from the common emitter configuration is denoted by symbol beta. Current gain, forward current gain of the common emitter configuration is denoted by symbol beta. But anybody can say the beta equal to what? Collector current by base current only. IC by IB, they will take. That ratio is said to be beta 1. The beta only can indicate the quality of the transistor. Anybody can say the range of beta is dash to dash. Anybody can give? What range of beta is given by the transistor? Anybody can give? Anybody can respond. The range of beta we can get from the common emitter configuration. Anybody? The range of beta we can get from? Anybody? Any idea or no idea? Gopi, can you give? Input impedance is a moderate, output impedance, but that is okay. I am asking the beta value you will get. That value comes within what range? IC by IB, no doubt. But what is the range of beta? What is the range of beta maintained mostly in common emitter configuration? It comes 22. The range of beta is nothing but 20 to 500. Within that range, they are going to maintain. 100 to 500, no, not calculable. The 20 to 500 only. Sir, students may get 100 to 500. Why not possible, sir? How can you say 20 to 500 only? Yes, we can give easily now. We know very well beta equal to what? Alpha by 1 minus alpha, we know from the electronic devices and circuits. But alpha, range of alpha, I gave already 0.95 to what? 0.998 I gave already. If alpha equal to what? Suppose you have taken alpha equal to 0.95, then beta value, it comes as 19, it comes mostly. If you are substituting here, no, 19, that is approximately equal to 20 they will use. Whenever you maintain alpha equal to what? 0.998, then beta value comes as what? Is a 499 approximately it comes. That is approximately equal to 500 they are going to take one now. So the range of beta is 20 to what? 500 it is maintained only. Understand? This is common emitter configuration now. But I gave the two configuration now, and third configuration we can go. Common collector configuration we can see now. The third one is common collector configuration. Common collector configuration. The next configuration is common collector configuration. But in this configuration, we can draw a diagram in this way. Suppose I selected with structure, otherwise you can take with symbol also, no problem. But I have taken PN, PR, and PN, your wish, no doubt. Common collector means collector is grounded here. This is nothing but the emitter. The output is taken between these two terminals only. The output across these two terminals. But here I am giving the input, this side. Input is given here now. But in this case, what now? This is the emitter current. This current is divided as a what now? IB and IC, they will put IB and IC. This is common collector configuration. Now, anybody can say the purpose of common collector configuration is dash and dash. Voltage gain more, current gain more, voltage gain less, current gain is a less. Current gain is a more, voltage gain is a less. Voltage gain, but all. Like that, certain options now. Which option is correct? Anybody can say the purpose of the common collector configuration. We can say the point number one. One more question you can expect. Wherever you want to get the what now, current voltage gain is a less. Voltage gain less. And current gain, whenever you want to get the more, you think it's so. You need to use common collector configuration. Common collector configuration. Very high input impedance. Very good. Exactly correct. Very high input impedance. It's 100% perfect one. Understand now. But a voltage gain is a less possible. Current gain is a more possible. Catch my point. Common base, what I said. Voltage gain more required. Current gain is a less is required. Means common base. Voltage gain is a moderate required. Current gain is a moderate required. Common emitter you said. Current gain is a more required, voltage gain is a less is required. You can use the what now common collector configuration. So this is the possible. Anybody can say the power gain from the what now common collector is a more or less. Anybody? Power gain from the common collector configuration is a more or less. Please respond immediately. Can you get more or less? The product of these two will give the power gain. I said already now. One is a high, one is a low, means power gain is available less only. One is a high, one is a low. 100% we can say power gain is less only possible here. Their voltage gain less, one is a voltage gain into current gain is a power gain. One is a high, one is a low, it comes low, But sometimes maybe chances to ask, the input impedance maintained for the what now common collector is a more or less. Input impedance is always high. Zin I will put otherwise. Input impedance is high. They will maintain. And output impedance is maintained less only. Why output impedance is a lesser? When the output impedance is less, current flow will be more possible. Current flow more possible means current gain available from the what now? This configuration is a more only possible now. But when the output impedance is a very low, drop is a low. When the voltage drop is a low, voltage gain will be decreasing only, you can say. That's why voltage gain will be decreased because of the what now? Common collector configuration only now. Understand my point now? So such a way we can give, understand. The quality of this transistor is a good or bad if you want to find gamma value required. How we can find the quality of the transistor? Output current by input current, IE by IB. Generally they will use IE by IB only. But suppose this gamma value I can get in this way. Gamma equal to IE by, suppose I divided in the numerator and denominator by IC for example. IB by IC. Then I can get directly. IE by IC is nothing but what? 1 by alpha only. IB by IC means 1 by beta, you know very well. But alpha in terms of beta we can write. Alpha in terms of beta means alpha equal to beta by 1 plus beta, everybody knows. From EDC, beta, beta cancel. Finally, gamma is nothing but 1 plus beta you can get. The value of gamma in common collector configuration is what means 1 plus beta times you can get only, you can say. So, these are the what now, the applications of the what now common base configuration now. What application? One is a high, one is a gate. So, one small table I will draw, clearly you can understand here now. Understand now. From the table, for 3 configurations I will draw. Suppose I selected here now voltage gain. This is nothing but the current gain. But I want to get the power gain also I am getting from this one. For different configurations we got here now. Those three configurations I put now. Common base you got already. Just understanding purpose easy now. Common emitter here. This is a common collector for example. But in voltage gain, what now voltage gain in common base I said more only. Current gain I said less only. Power gain I said less only. But the common emitter I said moderate. This is moderate. Current gain also moderate I said already. This is given already moderate. Power gain also moderate I said already. And common collector means voltage gain is a less I said already. And current gain is nothing but the what now in common collector more only I gave it. And power gain is also less I gave it now. Understand? Like that I gave it now. This I gave it now. Just as a one table I formed the what now for all these three configurations only. By using this what now table I want to ask one question. How many students can respond for this question? I will see the now. But from this diagram we can say where voltage gain more means common base no doubt. This is the more. First I will give the next I will ask the question you ask. Where current gain available more means current gain more we are getting from common collector only. Power gain where we can get more, I can get moderate is more as compared to other two, common emitter only now. So this is the power gain because mostly in the designing of the amplifier we are going to give importance to the what now? Power gain only now. But which stage, what now, which configuration gives more power that will be used practically only now. Common emitter we are using in any circuits only. Reason is what? Moderate what now? Power gain is available. So more power gain where we are getting means in common emitter only as compared to other two now. Now I am asking the question, how many students can respond clearly now? The power gain we can get from the common base is more, common collector is more. Anybody can respond? The power gain from the common base configuration is more, otherwise common collector configuration is more. That's my question. Anybody? Yes, Gopi gave common collector. Any others? From which configuration we can get the power gain of the more? I'm asking you now. Yes, Ravi Teja gave common collector. Gopi gave is the best. What is the best? Common collector only best you say. Anybody? Still I want. Where we can get the power gain of the more when you compared common base and common collector, that's my question. Yes, the same point you are, I'm asking the question, then you can understand which is right. But in the common base configuration, I got the less. Common collector, I got the less only. Now tell me without my help, less is less than less. Less is greater than less. Less equal to less. Which is right out of these three? Which is correct? From that one, you can get the answer correct. Which is right, you can understand. Less is less than less, impossible. Less is greater than less, not allowed. Less equal to less only now. Both are equal only now. In this case, power gain from the what common base, power gain from the common collector, both are less only, both are equal. The product of these two, voltage gain and current gain, you get it, some value you will get now. The power gain from the what now, voltage gain from the common collector, current gain from the what now, common collector, you multiply it. Finally, both will come approximately equal only now. Approximately equal it comes now. That's why you can say the power gain in the common base and common collector are more or less equal only we can say. We cannot say one is a higher, one is a lower here now. Understand my point now? Yes, this is the information regarding the configurations of the transistors only. Next, we can enter into biasing of the transistors. Biasing of transistor. Biasing of transistor. What is that biasing of transistor? Biasing of transistor means to maintain the collector current, because based upon the work only now problems will be done in the gates. All the gate questions are based upon the biasing of the transistors only. If a question you got from the transistor, only from the biasing of the transistor. Why biasing of the transistor is required? For the sake of maintaining the collector current constant only now. I want to maintain, once the designing of any circuit is made, their collector current and VCE value must be maintained common, constant only now. Quotient value of the transistor must be maintained constant. Q point of the transistor is to be maintained. If you want to maintain, biasing of the transistor is very important, I say. What I said? Operating point of the transistor is denoted by what? IC and VCE only. IC and VCE, common emitter configuration. These two parameters are given importance only. Collector current, generally they will maintain. The collector current depends upon certain factor. It is a function of what? Beta, and also ICBO or ICO or ICBO. ICBO can also be taken as ICBO also. Collector to base current when emitter is open circuited now. And also what you can say? VBE. Based upon these three factors only, IC value changes only. Collector current of any transistor depends upon three parameters. One is nothing but the beta, second one is nothing but the ICO, third one is nothing but the VBE only now. Any change of these values are taken place, 100% you can find the change of IC only now. That's why we should maintain this IC value constant, means we need to maintain these values constant only, you can say. Understand my point now? Anyhow, these three. The collector current for any configuration, collector current is general formula for the IC equal to what? General formula for IC is nothing but beta into IB plus 1 plus beta times of ICO or ICBO they will use. General formula for the collector current is this only. This is IC value. Otherwise, you can use one more formula, either IC equal to alpha into IE plus ICO also they will put. That also acceptable. IC equal to alpha into IE plus ICO also. But we are going to say IC value depends upon these three factors only. But what now? Why this formula here required means to find out the stability factor. These values are, this is the point is very important only now. Stability factor, the stability of any network can be calculated by what? No, stability factor only. By finding the stability factor, we can find the stability of the circuit only now. Understand now? That means stability of any circuit is inversely proportional to, catch my point, stability of circuit is directly proportional to what? 1 by stability factor. 1 by stability factor only. Inversely proportional. That is stability factor. Stability of the circuit is inversely proportional to stability factor, they will say. Stability factor is denoted by letter S. That means whenever the stability factor is what? Decreases, then only stability of the what? No, circuit will be increased only now. There's a practically S value must be maintained. Large or small means very, very small we need to maintain. S value must be very small. Then only stability of the circuit will be increasing more and more only, we can say. Understand now? But what is that stability factor? The stability factor S. Stability factor S means change of IC by change of ICO or ICBO. ICBO or ICO. Acceptable now. Change of IC by change of ICBO or IC is said to be stability factor one. That is the stability factor. That means S dash, one more they will put now. S dash means what is the meaning? Change of IC is taken place with a change of what? VBE, base to emitter voltage, is nothing but S dash only. S double dash they are going to use. S double dash means what you can say? Change of IC taken place because of change of beta is said to be S double dash only possible. This is possible. But you may get, sir, how that change of what now? ICBO changes means how IC changes. S value, please watch. Suppose it is what now? Circuit temperature is increasing, you think it's so. In any circuit, temperature is increasing, you think it's so. Immediately what now? Leakage current ICO also increases. ICO or ICBO will be increasing. Whenever ICO is increased, what is going to happen now? Whenever ICO is increased, once ICO is increased here, what is going to increase? IC also increases only. That's why once the what ICO increases means IC also increases only. That's possible. That means ICO increases means IC also increases. Both are increasing. The time it is a positive way, it is increasing only now. Understand now? Both are positive only. This is said what now? S is always positive, they will say. Why it is a positive? The increase of ICO increases IC only now. In case you have taken, but now second one you have taken, when temperature is increasing, S double dash, S dash what happens? Temperature increases means base to emitter voltage increases or decreases. Anybody? ICO is temperature dependence. Exactly correct. What you said is a correct, Gopi. The temperature dependence only. That's why when the temperature increases, ICO increases only. Understand now? Because of the breaking of the number of the covalent bonds, because what is going to happen now? Release of the what now? That leakage current possible here now. Now, in the second case, it will be when the temperature is increasing, base to emitter voltage increases or decreases only. Anybody? Whenever temperature is increased in the circuit, base to emitter voltage increases or decreases in the circuit. I am asking question now. Anybody can respond? Anybody can respond? Most in the electronic devices and circuits it comes. Whenever the temperature is increasing, base to emitter voltage increases or decreases. 100% it decreases only. Base to emitter voltage decreases when the temperature is increased. When base to emitter voltage is increased, what is going to happen now? Base current is going to be increased. That you will see in the what next circuits now. For the timing, you listen now. Base to temperature increases means base to emitter voltage decreases now. Base to emitter voltage decreases means base current is going to increase only now. How means very simple. For example, you have taken one transistor circuit in this way. There is a resistance I have taken here now, RB for example. This is nothing but the VBB I gave it for example. This current I have taken base current. How we can find the base current here now? I will find base current from what? VBB minus this voltage is VBE divided by RB we are going to use. Divided by RB1. But in the question what I said now, whenever the temperature is increased, VBE decreases now. VBE decreases means this voltage will be increased. Total voltage will be increasing. VBB minus VBE. VBE decrease means the difference will be increased. When the difference is increased, base current will be increased directly. That's why we are saying base current is increased as VBE is decreased only here now. That point is very important. Understand? Ankit, thank you. Thank you very much. Thank you very much. Yes, I can say the base current is going to be increased because the decrease of the VBE only. That's why IB, when VBE decreases, IB increases. When IB is increasing, IC also increases only, you can say. But in this case, what we can say, VBE, because of the temperature, VBE decreases, IC increases. The relation is opposite. Here ICO increases means IC is increased, positive we are saying. Positive that one. Whenever what happens, this is taken, the S is nothing but the positive. S dash is a positive or negative means 100% negative only we can say. Why sir? When VBE decreases, IC increases, opposite we are having. Opposite if you got it means what you can say, S dash will be taken as a negative only here now. And third one you check it now, S double dash, is it a positive or negative you identify. Beta value, when the temperature increases, beta value increases or decreases, anybody can respond. Anybody can respond. Beta value increases or decreases because of the increase of the temperature. That's my question. Anybody? When the temperature is increased, beta value increases or decreases or it remains constant. That's my question. Anybody? Yes, Gopi says increases. Very good. When the temperature is increasing, beta value also increases only. Once the beta value increases, you know very well, IC equal to beta into IB. Once the what now beta value increases, IC also increases only, 100% increases. That is why the increased beta, due to increase of temperature, beta increases, IC increases, both are increasing. 100% we can say it is a positive only. S double dash is said to be positive. Why we are saying positive? As beta increases, IC value also increases only. That's why we say it is a positive only, we can say. Understand my point now? And one more point I want to give clarity clearly now. But practically, the change of temperature, the increase of temperature changes beta, but not that much higher amount of the beta will be changing. The change of beta is a very small, there is a negligible amount only. When the change of beta is a negligible means why required? S double dash R. Mostly in the practical cases, what is going to happen now? When you are using any one of the transistor with beta equal to 100, you think it's so. Beta equal to 100, you selected, you connected there now. What is going to happen now? After a long period of the time, the transistor is damaged. What you will do? You replace with one more transistor only now. But with beta equal to 100 only, exactly same beta you will not get. Slight variation is possible there now. That variation changes the stability factor only, you can say. That's why what I wish to say, the replacement of the transistor will change the what now beta value. That is why stability factor changes and stability of the circuit also changes only now. That is the main cause of changing of S double dash also, we can say it. I think you followed this, understand now. Yes, that way biasing will be done now. Next one. S double dash 3 I gave it now. Next level. The 3 is given now. Next one what now? But how the what now different types of the biasing circuits we want to see here now. What are the biasing circuits? And also stability factor is very important now. Stability factor, how we can find stability factor general formula. 1 plus beta by 1 minus beta into DIB by DIC for any type of the configuration, whether it is a fixed biasing, whether it is a voltage divider biasing, whether it is a collector to base biasing, any biasing circuit you select now, you can find what S value is a common formula. This is the common formula for any biasing circuit. 100% you can use it now. Understand? The general formula for any biasing circuit is nothing but this is the formula only now. Understand? To find the stability. But anybody can say in designing the circuits, the stability factor is always maintained. Always maintain. How much value? How much value? Practically what value of S if you got, you will say the given circuit is a stable circuit. Anybody can say? Low value. Yes, everybody knows there is a low, everybody knows now. The low means in designing, they will have one boundary only now. Within that range, if you maintain S value, it is a good circuit they will consider. More than that particular number of the what now S value, if you got means they will reject the circuit only. So anybody can say the stability factor generally maintained in designing of the circuits is dash. Anybody can give? It's a low only. Low means what? Within what level they will use? That is my first question. Anybody? Less than 1. Less than 1. Very good. Catch my point. Mostly stability factor 0 if anybody is getting means 100% best circuit only. Stability factor is a 0, anybody is designed 100% perfect. But nobody can design with S equal to 0 value only. Impossible to design. Impossible now. But practically what they are saying, less than 1 is a very good only now. But in the practical application, S value is maintained always less than 8. Less than 8, up to less than 8, they will accept that circuit only. Up to less than 8, they will accept that circuit only now. Less than 1, if you design, very good. But in practical application, even the what now, the designer brought the circuit with less than 8, you think it's so. They are accepting only, you can say. Understand? That's why the S value stability factor is what now, practically it is maintained less than 8. Understand my point now. But they will maintain 1 in the books, they will get now. Still you went to the what now, depth, you will find S value must be less than 1. They were less than 8 also, they are maintaining practically only, can say. Understand point now. But in this case, what I said already, stability of the circuit depends upon the stability factor. Stability factor is reducing low and low. Stability factor, or the stability of the circuit will be increasing more and more. That point is very important. Now we can go to different types of the biasing circuits and stand now. Next one. The first one I want to take the fixed biasing. Fixed biasing circuit I want to take. In the fixed biasing circuit, the diagram, the circuit of the fixed biasing will be drawn in this way. Here connected with RC, here connected with VCC, here connected to the grounds. This is connected to the what now? RB. The current passing through this side will be taken as IC. The problems are based upon this only. Understand? If you followed all the biasing circuit, the formulas, if you are what now thorough 100%, you can do any problems in the gate. This current is to be taken as a IB. This current is IE, no doubt. This is the fixed biasing circuit. That way we can draw. But in the fixed biasing is a good circuit or bad circuit. Practically we can use it or we cannot use it. You need to understand that point. And what are those formulas will be used in the problems also you will find here now. How you watch. Beta is nothing but the current gain of the transistor only. Suppose in this network, currents IE, IB and IC are passing for a long period of the time. For a long period of the time, currents are passing in the network only. At the time, what is going to happen? Temperature is going to increase in the network only now. When the temperature is increased, catch my point. Whenever temperature is increasing, what is going to happen now? I said already, ICO increases only. Leakage current is going to be increased. ICO increases. ICO increases only. Whenever ICO is increased, base current, that is the IC will be increased or decreased. Anybody can say? Anybody can say the collector current is increased or decreased. ICO increases means IC also increases. 100% increases only. But the designing, what I said, the collector current we have to maintain constant only now. We should not change. It should not be changed even if the temperature is changing in the network only now. That must be maintained constant only now. But IC is changing due to change of temperature. At the time, it doesn't give the stability only, you can say. In the circuit, if you want to maintain the stability, you think it's so. You need to maintain collector current constant even if the fluctuation of the temperature is taken place in the circuit only now. That point is very important. But in this case, IC changes due to change of temperature now. IC changes means stable or unstable circuit. Finally, you tell me. Your judgment is what finally? 100% stability of this, poor stability only. Very good, Gopi. The stability of the circuit is a poor only possible. Understand? Poor stability is possible only now. So in this case, please watch. Base current is a variable or constant in the fixed biasing circuit. I am asking. It's unstable. Very good. Unstable. Now anybody can say the base current remains constant or variable in the fixed biasing circuit. In the fixed biasing circuit, base current is constant or variable. I am asking the question. Anybody can give answer. Base current is constant or variable. IC increases. What about base current? Increases or decreases? Anybody? Anybody can respond? Base current in the circuit increases or decreases? That is my question. Fixed, very good. That is the Gopi. Exactly. Fixed is a constant. The base current remains constant only. IB remains constant. IB remains constant, we can say. How can you say IB remains constant? Why you say it doesn't change even if the temperature is changed? Anybody? How can you say it doesn't get changed because of the increase of the temperature? Because here the base current is nothing but, catch my point, base current is nothing but the current across this RB. Current across this RB means voltage across RB means VCC minus VB by RB is nothing but IB only. What is IB means? VCC minus this side VB divide by what? RB only. But practically base to emitter voltage is 0.7 voltage only. It is not a much higher now. I can say in this one VCC is very large, very, very large as compared to VB only now. At the time we can neglect VB. Even you neglect it, doesn't matter now. So the base current is what now? Finally, approximately equal to what? VCC by RB we can get only now. IB is approximately equal to VCC by RB is possible. That is IB only now. But a VCC is a constant or variable. The source voltage 100% constant. RB is a constant or variable. RB is a fixed value. At the time base current also remains constant only, I can say. That's why what now? IB is constant only. That's why we are saying IB is constant in the network. Why it is constant, sir? As VCC and RB are constant, I say IB is also constant, sir. Yes, that's constant here now. Once the base current, but in this case, IC changes, IE changes, but base current not be changed. Now, fixed biasing, base current only constant. But practically, base current is not important. What must be maintained constant? IC must be constant. We are unable to maintain IC constant. That is why this circuit is an unstable circuit only now. How we can find the stability factor for this? Stability factor is, everybody knows very well. The stability factor equal to what? 1 plus beta by 1 minus beta into dIB by dIC only. I said already only. But here I got the what now? Base current equal to VCC by RB approximately. VCC by RB. Whenever differentiation is applied, dIB by DIC. dIB by DIC. Whenever differentiation is applied with respect to IC, there is no IC here now. Totally constant, 0 only. If it is 0, what happens now? S equal to what you will get? 1 plus beta. I will get only now. 1 plus this value becomes 0 only. Finally, S value is 1 plus beta. S value is 1 plus beta. So for fixed biasing, stability factor is 1 plus beta. So I said already, stability factor is a more, 100% stability is a less. Here what is the range of beta I gave it? 20 to 500 I gave it now. Suppose I selected beta value of minimum I have taken, for example. Is a 20 I have taken, 20 plus 1, 21 I can get now. Stability factor, minimum I am getting the 21 only. Minimum is a 21 means it is a worse now. It is not giving stability. I said in the practical designs, they are going to take less than 8 only now. We are getting the more than 8 only now. Minimum is a 21. Maximum is 501. 100% this circuit can provide the what now? Less stability only we can say now. That's possible from the what now? Fixed biasing. So the fixed biasing, these are the parameters very important now. We can go to next level now. Next biasing is nothing but suppose you have taken voltage divider biasing, for example. But maximum problems are based upon this voltage divider biasing only. Voltage divider biasing. Suppose I selected. Voltage divider biasing can also be called as a one more name, or voltage divider biasing, or it is said to be self biasing also we can call. Equivalent circuit of the voltage divider biasing is nothing but self biasing only, nothing more. Equivalent circuit of the voltage divider biasing is self biasing. Or one more name is there now. What is that now? And also we can say universal biasing. Universal biasing. Universal biasing circuit, because universally accepted this circuit. That's why it's given a name universal biasing only now. And I can draw a diagram in this way. This circuit is drawn in this way. There is a resistance RC. Here I connected with RE here. This is the VCC here connected here now. And here connected with two resistances only, R1 and R2 here connected only. This is R1, this is R2. This is nothing but voltage divider biasing circuit. Such a way we can, okay, exactly, potential divider also we can call. Any one of the name it is acceptable, understand. Potential divider biasing or voltage divider biasing or something it is given. But whenever the network is given like this, but why it is universally accepted means even if the temperature changes, 100% it gives the what now? Stability. It doesn't allow the change of IC more, very, very less. That's why they are going to say it's a stable circuit only now. But how the equivalent circuit, but in doing the problems, how the equivalent circuit is to be plotted? The equivalent circuit we can plot in this way. This circuit can be drawn in this way. There is a transistor. There is RE. And here I have taken RC. This is connected with a source VCC only now. Now what I did, the resistance, just I bended down this R1 this side. When I bended this R1 this side, I can get like this. This is R1. This R1 is connected to same VCC here now. And here the R2 it is existing this side. I can draw this R2 this side. I can draw in this way only now. So just I have drawn the what now? Modified form of the circuit only now. The problems also you will apply same methodology. Right, any voltage divider biasing. In this case, what you need to do, this is the open circuit, for example. I selected this as an open circuit. This transistor is removed. Finally, I got this circuit. Thevenin's equivalent circuit I want to draw. That means what now? Across these two terminals I can get VTH. When the view is made this side, I can get the what now? Resistance also. Thevenin's. That means this circuit I want to draw one voltage source. That voltage source is nothing but the VTH, and you will put the RTH value. This network is a redrawn Thevenin's equivalent circuit. Rest of circuit I connected only now. If I connected rest of circuit, I will get in this way. This is RE. And here I will connect RC here now. Here I can connect RC. This is connected with VC. If the Thevenin's voltage and Thevenin's resistance, if you connected, that network only we can call cell biasing circuit. This is cell biasing circuit one. Understand? So this is the cell biasing circuit, we can call it here. Sir, what is that VTH? How I can find the VTH in the problems while doing the problems? How I can find the VTH only? VTH, whenever you want to find, you can say when the VTH means voltage across this R2. If it is open circuited now, voltage across R2 is nothing but VCC into R2 by R1 plus R2. By using this formula, I can measure what is VTH here now. I can calculate what is VTH by using this formula in the problems. But if you want to, if the view is made this side, I can get the resistance. R1 and R2 comes in parallel only now. I can say RTH is calculated by R1 parallel to R2. I can write R1 R2 by R1 plus R2. So VTH and RTH we can calculate in this way only now. Suppose in the problem you are asked to find out the what now? Base current. Base current whenever you want to find in the problems, you must take this is IB. This current is IE. Emitter current is IE. That emitter current can also be taken as a 1 plus beta times of IB allowed. I will draw this side. Just watch. 1 plus beta times of IB also it is accepted. Then I will apply the KVL in this direction to find IB. In a problem, if you want to find the base current, KVL you apply. I can write VTH equal to, we can write VTH equal to RTH into IB. We know VTH, we know RTH. RTH into IB I can put. Plus from here to here some voltage drop. That voltage drop is VBE. Plus drop across this RE is nothing but 1 plus beta times of IB. 1 plus beta times of IB into RE only now. So by using, because in the problems he will give what is what is RTH you can calculate. VBE we know 0.7 voltage. Beta value he will give in the problem. RE value will be given in the problem. Then you can measure what? You can measure what value? Base current you can measure directly. So base current you can calculate by using this formula. Once the base current you are getting, you think is so, then you can measure what now? VCE value also. Suppose you are asked to find out the VCE value. VCE value, whenever you are asked, you must apply the KVL from top to bottom only. To find the what now? VCE value, top to bottom, you must take KVL now. How we can take here now? VCC equal to, I can write. To find the IC value, this current is IC here. IC into RC. IC into RC plus what? When you go down VCE here, plus VCE, plus when you go down RE into what? RE into 1 plus beta only. 1 plus beta into IB1. Yes, in the problem what now? IC value you can measure by using, but IC value also you can get. IC how I can get? Once I got the base current, catch my point. Once I got the base current, I can measure what now? IC also. IC equal to everybody knows beta into what? IB only. Beta will be given in the problem. Once the beta is given, beta into IB you multiply, immediately you are going to get what value? You will get the what now? VCE value. Then you can measure VCE value. Such a way VCE and IC and IB values you can use only. Here you watch in this problem we are using what? IC equal to beta into IB we are using. When we can use IC, what now? IC equal to beta into IB. Whenever transistor is in active mode only now. Only when the transistor is in active mode we need to use what? IC equal to beta into IB. IC equal to beta into IB is not acceptable for the what now when the transistor is in saturation. IC equal to beta into IB is not possible in the cutoff stage also, cutoff region also. What is that cutoff region? What is that saturation? What is that what now? Active region. Based upon this VCE only you can get now. In case, please watch, you can understand clearly. If, I will give clearly now. In case, if VCE you are getting less than 0.2 voltage, you think it's so. Whenever VCE you are getting the less than 0.2 voltage, you think it's so. You can say transistor is in saturation. Transistor is in saturation. Directly you can do in the, you can write in the problems only now. When the transistor, you can say when the transistor is in saturation, while calculating the what now VCE, if you got the less than 0.2 voltage, you can say directly the transistor is in saturation region only. In case if you are getting the VCE value, if you are getting the VCE value greater than 0.2 voltage, you think it's so. Greater than 0.2 voltage, you think it's so. You can say transistor is in what? Active mode only. Transistor is in active mode. You can write directly allowed, directly active mode it is, you can say. But when the transistor is in what now? Cutoff mode we can say. But the transistor, if in a problem, catch my point, if I is 0 only, main condition is that only. If I equal to 0, I must be 0 in the what now cutoff region only. If I is not 0, you cannot say there is a cutoff only. I must be 0. If I is 0 in the circuit, you can say transistor is in cutoff, I can say. Cutoff only. Still easy way, I will explain, please watch. You can understand clearly what is the region of operation now. Clearly. Suppose you have taken one transistor circuit this side. This is connected to the ground. I connected with RC here. I connected with VCC. I connected here with what? Some voltage. VBB, for example, I am using. VBB I am using. In case VBB, I have taken, for example, 0.1 voltage I use, for example. Transistor is made up of silicon, for example. Transistor is made up of silicon only. That means to operate this transistor, this is a NPN transistor here now. This is a NPN. It is acting just like a PN junction diode. Drop across, this is 0.7 volts. Whenever base to emitter voltage is 0.7 voltage required, connected base voltage is 0.1 voltage only. Can you say the transistor is on state? Anybody can say the transistor is in on state when VBB is nothing but 0.1 voltage? No, it doesn't operate only now. Less than 0.7, whenever you got, it doesn't flow. At the time, it can act as an open circuit. Emitter current is going to become 0 only. Base to emitter can act as an open circuit. That emitter current is going to be 0. When emitter current is 0, we are saying the transistor is cut off exactly. Suppose you have taken VBB equal to I want to take the what of 0.3 voltage. Even that case also what? Transistor is cut off only. That voltage will not be in a position to operate the what now? This PN junction diode. Even that I is a 0 only. I is 0 means it is in cut off only, we can say. Once you maintain VBB 0.7 voltage in this circuit, immediately what is going to happen? It is going to operate. It is going to operate. Once it is operated, what is going to happen? It comes to the active mode only now. It comes to active mode. Slowly you try to increase the what now? Base potential now. This is the VBB value. Slowly you increase, for example. By connecting the one more resistance RB, by connecting the RB, you try to increase the VBB value. Whenever the VBB you are increasing means base current also increasing slowly. When the base current is increasing, IC value increases more and more this side. Because now VBB, whenever you are increasing, it is in the active mode only. When it is in active mode, base current is increasing, IC also increases. IC equal to beta into IB. The increase of IC is done. But next what happens? At one particular voltage of VBB is maintained. What is going to happen now? Even the base current you are increasing more and more. The collector current will not be changed. The collector current remains constant. That is the saturation. Once it comes to the saturation level, IC is going to be maintained same value only now. It doesn't change. It doesn't depend upon the what now? this base current only now. It doesn't depend upon the base current now. At the time we are unable to apply what? IC equal to beta into IB only. That is the saturation point only now. Understand my point now? Such a way you can define now. Yes. Anyhow, I explained now what? Voltage divider biasing. In the voltage divider biasing, here required what now? One formula is more important. That is nothing but stability factor formula is more important now. Just I will give, please watch here now. Just wait 2 minutes. We are going to use the stability factor for this. Yes, stability factor for the voltage divider biasing is use this formula. You must mark up only this now. 1 plus beta by, we cannot derive that formula for the time being. No. Just I can give the formula only. 1 plus beta by 1 plus beta into 1 by RTH by RE plus 1 they will use. By using this formula only now, stability factor will be determined for voltage divider biasing or potential divider biasing. The stability factor is calculated by this formula. 1 plus beta by RTH means already I gave it how to find. RE value will be given, emitter resistance now. Beta value will be given. Then you can find the stability factor. That is voltage divider biasing only now. But the next one is nothing but collector to base biasing. I want to take here now. Collector to base biasing. Base biasing. Suppose in the problems you are given collector to base biasing in this way. Sometimes problems are asked by using this network also. Collector to base biasing means they will connect RC here connected with VCC. This emitter is connected to the ground. Emitter with a ground, emitter with a RE also they will connect now. I will give first ground only I have taken. And I connected one base resistance this side. I connected with a base resistance this side. If I connect it such a way, it is going to flow current. But after reaching to this point A, this voltage I can say VA. It is divided, some current this side IC, some current it will flow this side IB only. This side it can flow. IB plus IC, this can also be called as IE also we can put. IB plus IC we are getting. IB plus IC can be taken. IE only, no doubt. This is also IE only. Now, you please tell me now, the circuit is a good or bad? This can give the what now, more stability or less stability? Anybody? This is collector to base biasing. In this biasing circuit, can you get the more stability or less stability? You will get. That's my question. Anybody can react? Can you get more stability or less stability from this network? I'm asking. Anyone? Anyone can give? But this network also what now? It can give the what now? More stability only, this circuit mostly. But in this case, what happens now? Then how that when calculation will be done? Sometimes, but mostly it is required IC and VBE values only now. IC and VCE values required. Whenever you want to get the IC value, you must apply the KVL in this direction. By applying the KVL, you can get. When I apply the IB plus IC is nothing but IE, no doubt. Otherwise, this is nothing but 1 plus beta times of IB also we can write, no doubt. Initially, base current is required. If the circuit is given such a way, apply KVL and find the IB. VCC equal to, you must do problems in this way. But 1 plus beta into IB into RC. When you go this side, RB into IB, RB into IB. When you go this side, VBE here. By using this equation, you can measure IB. What is IB? You will get. That IB you can measure. That way, base current is calculated from this circuit only. Once the base current you got means, you can measure IC. IC equal to what? If it is in saturation, what? If it is in what now? Active mode, you will put IC equal to beta into IB. If it is in active mode. The transistor is in saturation mode, VCE must be taken 0.2 voltage only. If it is in saturation, you must take the 0.2 voltage. Now, anyhow, I assumed it is in active. It is in active means IC equal to beta into IB. Once I got the IC value, I can measure VB, what now? VCE also. We are in need of VCE. If you want to find the VCE value, you must apply the KVL from top to bottom. How I can apply? VCC equal to, I can note down here, VCC equal to, here I can put 1 plus beta, what now? But IC is required, but IC we got it here now. Here 1 plus beta into IB here, 1 plus beta into IB into what? Resistance RC plus, when I go down, this voltage is nothing but VCE only now. Or you can write VCE equal to this minus this drop only. So I can say VCE is nothing but VCC minus 1 plus beta into IB into RC, IB into RC. Yes, by what? Yes, that is only possible now. So by using this formula, we can measure VCE value. You may ask in the problem, find VCE, otherwise you will ask IC value. So by using these mathematical formulas, only the mathematical equations what you got from this network, we can find the VCE value. That way we can find. But suppose any student asks, sir, theoretically you tell me how the stability is all, we can do that also now. But now not possible now because the time period is very less. Anyhow, the stability factor I will give formula. Stability factor I can give only now. But in collector to base biasing, when the collector to base biasing is used, you will get stability factor in this way. 1 plus beta by 1 plus beta, this formula is used generally, into RC by beta into RC by, they will use RB plus RC they will use. So by using this formula only now, stability factor is calculated now. So that means collector to base biasing is given without emitter resistance. Without emitter resistance, whenever it is given, stability factor is taken. This is without emitter resistance, I say. Without emitter resistance. Without emitter resistance, we can say. Without emitter resistance now. Suppose if there is any emitter resistance, here we are having any emitter resistance for example. Whenever with emitter resistance means the formula will be taken like this now. With emitter resistance. But every formula will be changing. With the emitter resistance, directly stability factor I will give. With emitter resistance. Whenever the emitter resistance of RE is given, for example, in that case, the stability factor is calculated by 1 plus beta by 1 plus beta by 1 plus beta into RC plus RE, RC plus RE by RC plus RE by RB plus RC plus RE, RB plus RC plus RE. Yes, this is the formula it is applicable. To find out the stability factor with the emitter resistance they will use. But when RE is connected means all the formulas also changing. You can do by using that instead. This is nothing but these are the biasing circuits are generally used in the what now? Gate papers only now, understand now. And the next one. The next one is nothing but this small signal amplifier. Small signal amplifier. Small signal amplifier. But this is also a very important topic, gate point of view. But whenever the circuit is given, they will draw the small signal equivalent circuits. By using the small signal equivalent circuit only, voltage gain or current gain or input impedance or output impedance will be calculated only, we can say. But mostly in the small signal amplifier, 4 models you can find, 4 models only. The small signal amplifier, we are going to use mostly H parameter model, we are going to use H parameter model we can use. And second one is nothing but approximate H model also used. Approximate H model also used, or simplified H model also they will call, approximate H model. And third one is nothing but the RE model also used, RE model. Fourth one is nothing but R5 model also used. These are the model circuits you can find in the small signal amplifiers. But sir, for any circuit, I can apply any method. No, based upon the given data, we are going to use which method is the best one now. Understand now. When I can use H parameter models, sir, when I can use approximate H models, sir, when I can use RE or R5 models, sir. Suppose if you got a doubt, means I can inform. Suppose in a problem you are given all H parameters are given in the problem. HIE, HFE, HOE, like that all are given, for example. If all H parameters are given, you can use H parameter model. If all H parameters are given, you think it's so. All H parameters are given. All H parameters are given, you can use H parameter model. That model is possible. Suppose all H parameters are not given, if two H parameters are given, if two H parameters are given, you can apply what now? Approximate H model. Sir, only two H parameters means what those H parameters will be given? You will be given HFE and what now? HIE. These two H parameters are given in the common emitter amplifier. Common emitter HFE and HIE is given, you can use approximate H model. Suppose in a problem you are given only one H parameter is given. If it is given one H parameter only. If one H parameter is given, one H parameter. If one H parameter is given, one H parameter is given means what is that the H parameter? That H parameter is nothing but HIE. HIE is nothing but beta only. HIE is nothing but beta only. That HIE is given, you can apply RE or R5 model. Any model is acceptable. Only one H parameter is given in the problem, you think it's so. You can apply RE or R5. Choice is yours. I will apply the RE model, sir. Yes, apply. I will not apply RE. I will apply the R5, sir. Yes, you can apply R5. Any model is applicable only now. Anyhow, you got idea, I think. If all the H parameters are given in the problem, you are going to apply H parameter model. Only two H parameters, HFE and HIE are given, you need to apply the approximate H parameter. If only one H parameter is given, that is nothing but HFE. In that case, we are going to use the what now? RE or R5. Such a way, what now? The type of the model we have to select based upon the given data only now. So, what those formulae will be used in the what now? H parameter model now. I will give all the formulae. Using those formulas, you can do any problem only now. Just applying the formula only in H parameter model. First, I selected H parameter model. But out of these four, which method is the what now? Best methods are to find out the required gain, voltage gain or current gain or input impedance or output impedance I want to find means which method, which is best, sir. Whenever you are using the H parameter model, you think it's so, then only you will get what now? The gains of perfect or exact values. That means those values will give the what now? Close to the accuracy only now. More accurate values you can get voltage gain or current gain or input impedance or output impedance if given all H parameters only. That's why we can write H parameter model. But in this model, what I will to say, the formulas which are used are, I will give them now. Yes, in this case, in H parameter model, if you want to find out the current gain, you think it's so. Wherever it comes as a necessity to find the what now? Current gain. But it is given in the problem all H parameters in your hand, in the problem only. Load resistance also they will give. So what now? Source resistance also they will give. In that case, current gain formula is taken minus HF by 1 plus H naught into RL. This formula is generally used to find out the current gain. The deriving this formula also very simple. Just 2 or 3 lines if it is taken, it comes only now. Okay, here I am giving directly now. The current gain whenever you want to find minus HF by 1 plus HO into H naught into RL. RL is nothing but the load resistance one. In case you are asked in the problem input impedance, you think it's so. This is the current gain if you want to get me this formula. Current gain whenever you want to find, in that case you can use. But in case you want to find the input impedance, you think it's so. Input impedance is required. In case you want to find the input resistance or input impedance also we can call. This is denoted by letter Z0, Zi or Ri we can use. That value will be calculated by, that is calculated by Hi plus HR into AI, HR into AI into RL. Yes, this formula is generally used to find out the input impedance of the input impedance only now. The input impedance is calculated by this formula. In case you are asked to find out the voltage gain, you think it's so, by giving the all H parameters now, by giving the all H parameters in the problem, then you can use this formula. Voltage gain, if you want to find the voltage gain AV, you can use AI into RL, AI into RL by Zi. Zi is the input impedance. Yes, just directly substitution only. But in the problem is giving, RL is giving, and also is giving the values of H naught and HF and everything is giving now. Directly what now, by using the formula you can get now. So voltage gain I can get by using this formula. But suppose you want to find the output impedance, you think it's so. Output impedance, how we can get? Output impedance. If all H parameters are given, output impedance, that is nothing but Z naught. But in order directly output impedance is not possible to get in the problem. Initially you have to find the output admittance only. That is given a symbol Y naught. That Y naught is calculated by H naught. You have to mark up only, no other way, understand. H naught minus HR into HF, HR into HF divided by RS plus HI. RS plus HI they will use. By using this formula, Y naught is calculated. Once you are getting the Y naught, you think it's so, Z naught you can calculate. Z naught equal to 1 by Y naught. Yes, then you can measure the Z naught value. So, in H parameter model, you are going to use, these are the formulas to get the answer. If it is a, what now, approximate H model, you think it's so, how we can do, I will give. The clarity I will give. Just by drawing this circuit, I will give clearly now, understand now. Next one. Next one is approximate H model. Approximate H model. Approximate H model. How this approximate H model you can use, that is very important. In approximate H model, what you can do? Suppose you are given, you can understand clearly, just by giving the one circuit I will explain, then you can understand how to apply the what now, approximate H model only. Suppose you are asked, I am asking the question, you can understand. Find Zi, I ask suppose, Z naught and what now? Voltage gain. Generally you will ask voltage gain only the problem. Generally voltage gain only. Using approximate H model, for example. Using approximate H model. Approximate H model. Using approximate H model means what you can do, you must take, suppose the circuit is given like this. The problems will use circuit in this way. There is RC here. This is the VCC is given here. And it is connected with the ground. Here connected with what? There is a RE, for example, now we can put. There is RE. That RE is connected to the what now? Bypass capacitor CE. And here connected with voltage divider biasing is given like this. This is given R1, this is given R2. But the input is given this side, capacitor is there now here connected with a source, Vi is connected here now. This is Vi. The output is taken across these two terminals only now. That way they are taking the outputs. This is the given network. From the given network, how we can find Zi and Z0 and also what voltage gain, that is more important. Then what now, by using the approximate H model is given, you need to plot the what now? AC equivalent circuit for the given question only. AC equivalent circuit means what you must do? Under AC analysis, wherever the DC source is given, that must be shorted only. Under AC analysis, wherever you got the DC source, that must be short circuited now. Wherever capacitor is connected, that must be short circuited under AC analysis. Wherever capacitor is connected here now, they must be short circuited now. This is short circuited one. In that case, how the network I can get here now? Vi is connected to the ground. Yes, I will draw. The Vi under the AC analysis, Vi is connected to the ground. Yes, I will draw Vi to the ground. That's my point. And next one, what is given here now? And also capacitor must be shorted, I said no. Yes, we can do. Capacitor must be shorted. Yes, I shorted here now. Next one. In the network, what is given still? But whenever the DC source is grounded here now, shorted, R1 is connected to the ground. R2 also connected to the ground only. I can say R1 is connected to the ground and R2 also connected to the ground. R2 also connected to the ground only now. Those two are grounded because R1 to the ground, R2 to the ground also. And there is a transistor. The transistor equivalent circuit, it is to be plotted in this way. In the AC analysis, wherever under approximate model, transistor equivalent circuit, we can draw in this way. Resistance with current source, they will draw. This is the AC equivalent circuit only. But the resistance is taken as a HIE for common emitter, HIE. This current is nothing but beta into IB because this current is the IB only. Beta into IB. So this is the equivalent circuit for the transistor in approximate H model. Directly you can plot. There is a transistor. Next we got the transistor. Please watch here. We got one transistor here now. The transistor equivalent circuit is nothing but I can draw. There is a resistance HIE and this side I got the beta into IB. Yes, that current source I have taken as it is. This current I have taken as a beta into IB only because this current is IB. That is taken here now. Next. Now you watch here now. Whenever this capacitor is shorted, no current because RE cannot have any effects. That can be removed. Directly it is shorted only now. That's why I can take here now. Next one is nothing but this is grounded only. This is grounded directly. Shorted only. The next one what we got here now, RC is connected to the ground only because VCC is shorted. RC to the ground it is connected. Yes, RC to the ground I can put directly. This RC will be connected to the ground only. And also in the procedure you watch it now, here the capacitor is shorted, we are receiving the V0. By shorting the what now, that capacitor I will get the V0 only now. I can say this will be shorted and we are receiving the V0 only now. We are receiving the V0. This is the equivalent circuit we are getting. These are all grounded only, you can combine. That circuit we are getting now. This is finally taken as a what now? But the beta can also be HIB. This also can be written as a HIE. Beta can be written HFE also. HFE into IB also we can write, no problem. Beta is nothing but HFE only. In H parameters, we can note down like this one. And suppose when you want to find the input impedance, you think it's so. These three are in parallel. You can get, suppose you want to find the input impedance, you think it's so. Directly you can get Zi is nothing but when the view is made, these three are in parallel. R1 parallel to R2 parallel to what? HIE. HIE, I can write HIE. By using this, I can measure the Zi value. 3 are in parallel. You use it, you'll get. But I want to find the output impedance. The view is to be made this side. When the view is made this side, you can get the output impedance only now. I can get output impedance when the view is made this side only now. But to find the output impedance, condition is there. What condition you have to apply? But the input voltage source, whatever it is given, that must be shorted. That's my point. To find the, I say, to find output impedance, what do you have to do? Input voltage source must be shorted. Input voltage source must be shorted. That is very, very important. Must be shorted only now. This must be shorted. And also what you must do, the output, the V0 is there, but the output terminals must be connected by the source only now. Output must be connected by the source only now. Understand now? Output must be connected by the source. In that case, whenever the source is shorted, catch my point. Whenever it is a shorted, what is going to happen now? Base current is what? What base current will flow? When it is not existing any source, the base current is going to become 0 only. 0 amperes possible. Whenever the base current is 0, this total value becomes 0 only. Current source is 0. Current source is 0 means it can act as an open circuit only. This can act as an open circuit. Finally, Z0 equal to what I can find? RC only I can find, because it is an open circuit now. When the voltage source, input voltage is shorted, I said, it doesn't have any source at the input side, base current is going to become 0 only. Once the base current is 0, what is going to happen now? This current becomes a 0, because HFE into IB 0, total current is 0. Once this current is 0, this can act as an open circuit. Current source can act as an open circuit. Finally, Z0 equal to what I can get? RC only I can get now. So I can write what is Z0 if I ask, you can write directly RC only possible now. RC is possible now. Suppose the voltage gain is required. How we can find the voltage gain from this network? Voltage gain, whenever you want to get output voltage by input voltage, is nothing but the voltage gain only. How I can get the voltage gain? First you find what is V0 here now. You find what is V0 in the problem. V0 means voltage across this RC. Current into resistance, same current will pass this side. Current into resistance. Current into resistance. V0 here, current is in reverse. Reverse means I can write minus HFE into IB into RC I can put. Into RC I can put here. But to find the output impedance, I am shorting only now. Whenever you are finding the voltage gain, it should not be sorted. You must have the VI only here now. VI is a must, understand. If this voltage is VI, this voltage also what? Same VI only. Parallel, that's why. So here the base current is required. Base current you can find VI by HIE. VI by HIE we can use. And finally, what is V0 I am getting here now? Minus HFE. The IB is nothing but VI by HIE into what? RC I can get here now. But I want voltage gain. Voltage gain is nothing but V0 by VI only. V0 by VI is nothing but minus HFE into RE minus HFE into RC by HIE I can write. Yes, by using this formula, like that voltage gain you can determine. That's why input impedance or output impedance or voltage gain, by using the approximate H model, we can calculate in this way. Suppose in the network suppose the question was given by using the RE model, you find out the value. How RE model means now? Only two H parameters, that means HFE and HIE are given, you think it so. You will apply this formula. HFE and HIE is given, only two H parameters are given. That is why you are using this formula, approximate H model. In case only one H parameter is given, we can see RE model, for example. RE model we can write. In RE model, what they will do, suppose there is a circuit like this, for example, you can understand clearly. Suppose you are given a circuit in this way. This is RC, for example. Suppose I ask find voltage gain, I ask for example. Find AV. Mostly you will ask voltage gain only the problems. Voltage gain, whenever you want to find for this circuit, you think it's so. Suppose you are given here RE and it is connected with what now? One capacitor. Bypass capacitor is given CE. And here it is a shorted, but a capacitor is connected. Output is taken from here now. Here I got VCC. And this is connected with what? Resistances R1 and R2. Here I connected one. These two resistances are given only now. Here I connected with a capacitor and connected with a source, VI only now. Such a way network is given. Suppose you want to find the what now? Only HFE is given in the problem. Only HFE is given. HFE means beta value only now. In that case, how we can find the voltage gain? First, you need to draw the AC equivalent circuit. According to AC equivalent circuit, what you must do? VI must be connected to the ground. VI to the ground must. And capacitor must be shorted. Wherever DC source is given, that must be shorted only. Then R1 to the ground, R2 to the ground you will get. R1 to the ground, and also I can connect R2 to the ground. This also I can connect to the ground only. Both are connected to the ground only. The transistor equivalent circuit in RE model we can draw like this. Suppose you are given at anywhere in the problem, a transistor is given. That equivalent circuit just like a what now? Approximate H model, one resistance, and also we need to have the what? One current source now. This is the base current IB. The resistance is taken as a 1 plus beta times of, or 1 plus beta times, or beta into RE we can write. Mostly 1 plus beta into RE. 1 is a very small as compared to beta. 1 they will neglect. Beta into RE is enough. But this current is taken beta into IB only. This value will be taken. I'll put just wait. But this value will be calculated by beta into IB only. This is the equivalent circuit only now. This is the equivalent circuit for the transistor. So here I got a transistor, that circuit, what the transistor equivalent circuit in a RE model I can take one resistance and also with one current source. One current source. That current source is taken beta into IB here. This is taken beta into RE. And here what now? This is grounded one, because whenever the capacitor is grounded, it doesn't have any effect of RE only. It is a shorted only. Whenever it is a shorted, I can connect to the ground only now. Understand now. But this side I can get what? Capacitor is shorted, RC is connected to the ground. RC to the ground, because RC to the ground, VCC is shorted now. And also we got the what a capacitor is shorted, I can get the V0 value. Such a way AC equivalent circuit is to be plotted. This is said to be AC equivalent circuit. AC equivalent. This is AC equivalent circuit I can say. This is said to be AC equivalent circuit. Once you are getting the AC equivalent circuit, you think it's so. You can measure gain. V0 you calculate. V0 means voltage across RC I can say. Voltage across RC means current into resistance. Current is in reverse, minus beta into IB. Minus beta into IB into RC I can note down here. What is IB? IB you will calculate from this only now. This current is IB, no doubt. The voltage across this beta into RE is to be taken VI only. So VI by IB I can take VI by beta into RE I can write. Beta into RE. Then I can write that V0 is nothing but minus beta into IB is nothing but VI by beta into RE into RC only now. Into RC. But a V0 by VI is nothing but I can write voltage gain. Whenever you want to find the voltage gain, just wait. Whenever you want to get the voltage gain, you think it's so. Whenever you want to find the voltage gain, you think it's so. V0 by VI is must. V0 by VI is must. What V0 by VI I can get from this? That I can get from V0 by VI is nothing but beta beta cancel minus RC by RE only. Minus RC by RE. RC by RE. RE means emitter resistance. But in the problems, how you will determine the RE value? RE value, you need to find thermal equivalent of voltage by you must use emitter current only. VT by IE. VT means thermal equivalent of voltage. IE and IC are approximately equals in the problem. IE is approximately equal to IC you must take. Under DC analysis, IE value must be, under DC analysis you must take. Analysis, by using the DC analysis, IE is required. Thermal equivalent of the voltage you know very well, 26 millivolts only we are going to. If it is given 25, sometimes they will give 25 millivolts also. At the time that voltage is to be taken in the problem only. Anyhow, we can find the RE by using this. RC will give in the problem. Directly you can find the voltage gain only now. This is nothing but RE model we can say. Once you followed RE model means not required R pi model also. Any one of the model is enough. You can use these are R pi or RE only. So I said anyhow, this RE model you can follow only now. Understand? Next one. And sometimes in the problems you can expect what now? Current mirror biasing circuits you will ask. You will give. Current mirror biasing circuit. Current mirror biasing circuit. Asking sometimes in the gauge. The current mirror biasing circuits are given like this. They will give in this way. And they will connect here now, sorry. But here the transistor is connected now, here connected with RC for example. Here connected with VCC. This is shorted this side and one more transistor is connected this side. The current passing through this side is nothing but I reference I have taken for example. I reference. But this is nothing but transistor Q1, this is the transistor Q2 I have taken now. Current passing through this side I have taken IC2 for example. The collector current of the first transistor I want to take it as IC1 I have taken here now. These two transistors are connected to the what now? Ground only now. These two are connected to the ground. Questions will be given like this. This type of the questions asked many times in the gate only now. But he may ask to find out the what IC2 value in the problem. Otherwise, you will ask resistance RC how much here now. RC value or IC2 value, any one of the question you will ask only now. Where current mirror biasing circuits are used generally? Where current mirror biasing circuits are used? Anybody can give answer? Any student can say where current mirror biasing circuits are used. Anybody? Anybody can respond for this? Where we can use current mirror biasing circuit? But in the differential amplifiers, we are going to use the what now current source at the emitter only now. Emitter is connected with emitter what now current source only. The current equivalent circuit is what now? Current equivalent circuit is used current mirror biasing circuit only. In the electronic circuitry, wherever the current source is required, there you can use current mirror biasing circuit only. That means that constant current is going to flow in the network only now. So in the place of current source, we are going to use current mirror biasing circuit only now. How we can measure IC2 and IC1? But in this case, in the current mirror biasing circuits, this is a transistor Q1 and transistor Q2 are made up of same material only now. The beta values are maintained same only now. Beta value will not be differed only now. So both transistors are made up of same type of the material only. Beta values are same in the circuitry only now. But in this case, what happened now? The first transistor is what now? Here, just a shorted one now. Whenever you are shorting here now, it can act just like a PN junction diode. It can work only, we can say. Second transistor you got, that will be maintained in the active region only always. That will be in the active region only in the current mirror biasing circuit. But anyhow, how we can measure IC2 means please watch. But these two what now? Transistors are made up of same materials, beta value same is base current will be maintained same only now. If this current is a IB1, you assume for example. Beta values are same. So beta values are same means what now? IB1 and also what now? When the KVL is applied this side and this side, what is going to happen now? Same amount of the what now potentials you are going to have in parallel connection. And also currents of same will flow this side only. This is IB2 I can write now. This is also same IB1, same current will pass both sides only now. Both sides it will flow the same current only now. Understand? because beta value same, IC values also. IC1 and IC2 will be same. IC1 and IC2 are same in this case. When IC1 and IC2 are same, why? Because base currents are same. When base currents are same is beta into this base current, beta into this base current. IC1, IC2 will come same only now. What net current is passing this side? 2IB1 I can say. 2IB1 it can flow totally. Finally, what is I reference I ask? Can you find what is the I reference? It can flow in the network only. I reference is calculated by IC1 plus, I can write IC1 plus, what I can write? 2IB1. 2IB1 I can write. And base current you can measure by one more way also. I reference I can find IC1 plus what? 2 into IB1. IB1 is nothing but IB1 can be calculated by IC1 by beta also we can write. IC1 by beta. And I want to take IC1 in common. I reference equal to IC1 into what? 1 plus 2 by beta I can get in this case. So we know very well when the two transistors are made up of same material, beta values are same I said. In this case we can find IC1 and IC2 are equal. So I reference I can write, I reference can also be written IC1 equal to IC2 also acceptable. 1 plus 2 by beta I can get here now. And finally what is IC2? If I ask, you can use this formula. IC2 is calculated by I reference by 1 plus 2 by beta. Yes, this formula we can use. Whenever in the problem you are given current mirror biasing circuit, you are asked to find out the IC2 value means, but you will give I reference in the problem. I reference you will give. I reference is not given means you must apply the KVL. Not given you think it's so. In this case you can find I reference is calculated by, how we can find? You apply the KVL in this direction. When I apply the KVL, I reference I can find input minus output by resistance only. I reference I can find VCC minus VBE by what? RC. By using this formula you can find I reference. So VCC will give VBE 0.7, RC value will be given, then you can find I reference only now. So beta value is given, you think it's so. When the beta value is given in the problem, you must use this formula. But in this current mirror biasing circuit, beta value is always maintained very, very large. Beta value must be very large one. Suppose you are given beta is very large in the problem, suppose. If beta is very large is given, not given large means you can use this formula. Beta given means this formula you apply to find the IC2. To find the IC2, this formula you apply. If beta is large is given in the problem, you think it's so. Beta is large is given in the problem. What I can do, 2 by large value, smaller value, negligible. Then directly IC2 equal to what I can get? I reference I can get only now. These two are equal, I can say. IC2 and I reference are equal. The beta value is very large. If it is very large, this is a very small. Finally, IC2, I reference. Try to understand. In a problem, if you are given beta value is a very large, IC2 and I reference must be same. IC2 and I reference must be same. In case beta value is given, you think it's so. At the time, IC2 and I reference are not equal. IC2 equal to I reference by 1 plus 2 by beta you need to apply. That way we can calculate the what now? Current of IC2 only now. This is the methodology is required. This is current mirror biasing circuit. And sometimes in the problems you will give Darlington amplifier. Sometimes you will give problems from the Darlington amplifier. If you are given the Darlington amplifier means how we can do the problem. The Darlington amplifier, what happens now? They will connect the what now circuit in this way. Two transistors will be connected this side, and this is connected with one emitter resistance only. RE will be connected this side. And these two transistors are connected to the one source, common source they will connect. That source is to be taken as a VCC only. That source is taken VCC only now. And this is connected with what? Resistance RB. Base resistance here will be given VBB. This is said to be Darlington amplifier. But what is the purpose of Darlington amplifier? The importance of the Darlington amplifier is nothing but to get the more current gain. When you want to get the what now more current gain, you think it's so, you can use the Darlington amplifier only now. More current gain we know very well, we can get from the common collector amplifier generally even now. But a single stage common collector amplifier cannot give the required amount of the what now current gain only now. When we are not in a position to get the more amount of the current gain from the single common collector configuration, we need to use the Darlington amplifier only now. The Darlington amplifier can also be explained as a what now, the cascading of two common collector amplifier only. But here we are using the emitter follower only. RE is connected to the ground, V0 is taken across the RE only, emitter follower. Emitter follower can act as a common collector. That is why the two common collectors are cascaded only now. But in this problem, we will ask to find out the what now? IE or IB only, collector current or otherwise base current, or otherwise you will ask emitter current only. How we can measure IE, you ask. This current, the current passing through this RB, I wish to take it as a IB only. This current is the base current IB only now. This current I want to take it as IX. IX is nothing but the base current of the what? IX may be what? Emitter current of the first transistor, IE1 we can say. Otherwise, IX can be what? Base current of the second transistor also, IB2 also we can write. But I am in need of this current. What current? IE is required. How we can find IE in the problems? That is more important. Asking in the gate, IE or IB in the problems only. How we can measure? This current I have taken IX. IX may be emitter current of the first transistor or base current of the second transistor only now. But can you say what is IX? IE1, how we can measure IE1? IE1 can also be taken IX also, no doubt. But everybody knows before, what now, in before, I gave the what now formula, emitter current equal to 1 plus beta times of IB also, 1 plus beta times of base current. What is the base current here now? Base current of the first transistor, 1 plus beta times of IB, that is IX only, that is IX. But that IX also is equal to what? IB2 also. IX also equal to IB2 only. Suppose I ask, can you find the IE value? I ask, can you find the IE value? This IE depends upon this base current only. IE depends upon this base current. So IE equal to what I can write? 1 plus beta times of IB2 only. IB2. We got already IB2. IB2 equal to 1 plus beta into IB. Directly I can measure emitter current by using this formula. 1 plus beta here. That IB2 is nothing but 1 plus beta times of IB I can write here directly. So I can write directly emitter current is nothing but 1 plus beta whole square, 1 plus beta whole square into what? IB. By using this formula you can measure the emitter current only, you can say. But in the problem you are given beta values of both transistors are same, you can use this formula only now. In case the first transistor and second transistor can have the beta values of different, it is given beta 1 and beta 2, you think it's so. In that case, emitter current you can find 1 plus beta 1 into 1 plus beta 2 into what? IB is to be used only now. That way we can do the what now? This current. This is Darlington amplifier work only now. Next one. Next one is nothing but the feedback amplifiers we can use. Feedback amplifier. Feedback amplifier. But how many types of feedback amplifiers we are using? Yes, Manoj Kumar 1 plus beta by 1 plus beta square into IB. Exactly correct. Yes, exactly correct. Yes, Manoj Kumar, exactly you give answer only now. Understand now. Yes, in this case, feedback amplifier. In the feedback amplifier, how many types of the feedback amplifiers we are using? Two types means what? Amardeep Singh. Positive and VE. Positive and VE means I don't understand. Okay, otherwise one more way if you want means I can do, no problem. Okay, one more type you want to have? Okay, I will give otherwise. One more type means mostly you can expect this way. I'll give clearly now. Suppose in the Darlington amplifier, we don't have one more type where you got here now. Only one type only, positive terminal. Positive and negative value now. Yes, they will not give. This is one model only will come. Two types, no. Darlington amplifier is a one only now. If it is given what now, the current mirror biasing circuits means you will use now, understand. Mostly we are going to have in the gate this model only, understand now. Next one, feedback amplifier. Feedback amplifier, you can say. But in feedback amplifiers, what I can do, two types of the feedbacks we are going to use only now. Two types of the feedbacks we are going to use, negative feedback and positive feedback. I'm asking the questions, how many students can give answer? But where we are going to use the negative feedback? Anybody? In designing what you will use the negative feedback? In designing, what to design you will use the negative feedback? Anybody? What to design you can use negative feedback? Anybody? To design the amplifier only. To design the amplifier, we are going to use the negative feedback only. To design the oscillator circuits, we are going to use the what now? Positive feedback only now. So positive feedback is applicable for the what now? Designing of the oscillators now. And this is negative feedback for designing the amplifiers only, we can say. Understand my point now. So what are the certain characteristics are required now? Using those characteristics only, we can get the what now? Formulas only now. I say, the feedback amplifier now, effect of the negative feedback I want to take. Effect of negative feedback. Effect of negative feedback on amplifier characteristics. An amplifier characteristics, I say. An amplifier characteristics, I say. But the negative feedback is going to increase the what? Negative feedback is increase the gain or decreases the gain only? That's my question. Negative feedback increases the gain or decreases the gain? Anybody? Anybody can answer that? Decreases the gain only. Negative feedback is going to decrease the gain. That is why feedback gain will be calculated by what? A by 1 plus A beta they will use only. A by 1 plus A beta. That means the gain will be reduced by using the what? Negative feedback. A is nothing but the open loop gain. AF, but then AF means feedback gain. 1 plus A beta times the gain will be reduced by the what? Negative feedback only, we can say only now. But in this case, what now? In this case, next one, what now? But because of the negative feedback, the bandwidth will be increased or decreased, I am asking now. Anybody can say? The bandwidth is going to be increased or decreased because of the negative feedback. Anybody? Bandwidth is increased or decreased? Manoj Kumar, can you give? Gain is reduced means bandwidth will be increasing only now. Bandwidth is going to be increased. That's why you can say, because the negative feedback bandwidth is increased, we can say. Bandwidth is increased. The bandwidth is because of bandwidth, how we can calculate? Bandwidth after feedback is calculated by FHF, high cutoff frequency after feedback, low cutoff frequency. Just wait. But FHF minus FLF they are going to use. FLF we can write. But mostly what now? FLF will be decreased. FLF is calculated by FL by 1 plus A beta. Low cutoff frequency after feedback will be reduced. But what happened now? High cutoff frequency, FHF, if it is taken, it is going to increase. Increase means you have to multiply. 1 plus A beta times of what? FS they will use. By using this formula, high cutoff frequency will be calculated. Whenever these two values you are substituting, bandwidth after feedback you can calculate in the problem solving. So the feedback after the what? After what now? But bandwidth will be increased because of the feedback only, we can say mostly now. Understand? This is very important. What about the output noise? Because of the negative feedback, output noise will be increased or decreased? 100% decrease. How much times it is decreased? 1 plus A beta times, reducing only now. Third point, we can say output noise, if it is taken, input noise will be reduced by 1 plus A beta times. The time output noise will be decreased only now. That will be used. The percentage change of gain, sometimes in the problems you will ask, percentage change of gain after feedback. Percentage change of gain after feedback, whenever you want to find, you need to use this formula only. percentage change of the gain after feedback will be calculated by 1 by 1 plus A beta into, they will apply the dA. dA by A into 100 they will use, into 100. That formula they will use. Percentage, what now? Change of the gain after feedback, if you want to calculate, this is used now. Generally used formulas I am giving you now. Sometimes in the feedback amplifier, they will ask sensitivity, you calculate. Sensitivity, if you want to find in the negative feedback amplifier, so think it so. Sensitivity must be 1 by 1 plus A beta, they will apply. 1 by 1 plus A beta is called as a sensitivity one. Sometimes may be chance to ask desensitivity. Reciprocal of the sensitivity is said to be desensitivity. Suppose you are asked to find out the desensitivity, you think it's so. Desensitivity. You must use in the problems what? 1 plus A beta 1. 1 plus A beta. Reciprocal of the sensitivity is said to be what? Desensitivity. And here the loop, but anyhow we are going to use these are the formulas in the what now? Negative feedback amplifiers only now. But sometimes in the problem, the questions is what now asking, in voltage series feedback amplifier, RIF value, ROIF value. Voltage shunt if it is given, RIF and ROIF required. How easily we can do, you ask now. We no need to muck up directly by watching the name, you can get the what now formula. In the problems you can apply that now. I will give clearly, you ask. Suppose you are given in the problem voltage series feedback. Voltage series feedback. If you are given voltage series feedback, you think it's so. But input impedance and output impedance we can consider now. But input impedance is increased. What is the formula you can apply for the what now? RIF value, how much? Anybody can say? When you are given voltage series will be taken as a input only now, input circuit. Wherever the voltage is given, that must be taken as a output circuit only now. That must be taken output circuit one. Input is given series circuit. In the series circuit, total resistance will be increasing or decreasing. Anybody? In the series circuit, total resistance will be increased or decreased. 100% increases. Whenever the shunt connection is given, resistance will be decreased only now. But in this question, what happened now? In the voltage series feedback, whenever the problem you are given voltage series feedback, data is given, you are asked to find out the what now? RIF. RIF you ask means what to do. Now I say in voltage series, RIF what now? Series given means it is increasing. Increasing means you must multiply 1 plus A beta. Decrease means divide only now. 1 plus A beta times of RI. That is the RIF is possible. RIF increases in voltage series feedback amplifier. What about input side? But output? Output is from the voltage. Voltage, what happened? Voltage means it is a series or parallel network. Voltage where you can find equal. Voltage whenever it is given, it is a shunt connection only. Whenever in the question voltage is specified, because in the parallel connection only you can find voltage as equal only. Voltage indicates shunt. Series indicates, we know very good. Shunt. In the shunt connection you can find the what now? Resistance of the more or less. In the shunt connection, resistance is always less only possible now. Parallel connection, resistance decreases. That's why ROF, output impedance after feedback will be decreased. Decrease means what you have to do? R0 by 1 plus A beta we can write. This is the formula we are going to do. No need to mark up directly by using the what now? That name we need to form the formulas. Then we can do problems. R0 will give, A value will give, beta value will give. Directly you can get answer on it. And sometimes what is going to happen now, it is a voltage shunt is given, for example, in a question. Whenever you are given voltage shunt feedback is given, suppose. Voltage shunt is given. If it is a voltage shunt, what you have to do? How we can form the RIF and ROIF to do the problem? RIF, what now? Voltage shunt, this indicates input circuit only, I said already. This indicates output circuit only. In shunt connection means parallel connection. In parallel connection, total resistance will be decreased. That is why RI is decreased after feedback. RI is decreased means it must be divided by, RI must be divided by 1 plus A beta. Direct formula we can write. And what about ROFs are? ROFs are. but our output is the voltage. Voltage means it is a shunt connection only. In the shunt connection, resistance will be decreasing now. Decreasing means R naught by what? R naught by 1 plus A beta. It is also decreased. We can write now. That is voltage shunt feedback only now. In case, yes, very good. Manoj decreases now. Manoj Kumar, very good. Next one. Suppose you are given what now? Current series feedback. Current series. Now you tell me without my help. Current series feedback, suppose you are given in the problems. Because this is the main purpose of this session is to give the formulas only now. Understand what those formulas will be useful to make a score in the gate only now. Understand now what they are useful only now. In the current series, what happened now? This is nothing but the input circuit. This is going to become a output circuit only. Now you tell me without my help, input impedance after input resistance after feedback will be increased or decreased. That's my question. RIF increases or decreases in this case. RIF increases or decreases. That's my question. Anybody? RIF increases or decreases. Input is the series connection. Series indicates what? Resistance increases only. That's why RIF increases. That means RI increases means RI is to be multiplied by what? 1 plus A beta, we can write. Series, in the series connection, resistance will be increased only now. But what about ROIFs are? ROIF means, what I can take? ROIF means it's a current. Current means what? Current means what? Now series connection is a series connection only now. Current indicates series connection because current is same in the series circuit only. Shunt connection, but it is a voltage given means parallel I said now. Current given means you need to think that is nothing but the series connection. But current indicates output also series. Series means what happen now? Output impedance also increases only. 1 plus A beta times it is going to be increased only. Current indicates series. In the series connection, it is going to be increased. There is a voltage shunt, I can say. And next one is nothing but voltage series over and voltage shunt is over. Sorry, same voltage shunt I gave it again. Current series I gave it now. Current series we have done. Current series. Next one, current shunt we can take for example. Current shunt I gave it for example. Current shunt. Now you tell me without my help. But in current shunt, can you give RIF and ROIF here? What is RIF here now? Shunt indicates parallel input circuit. Current indicates output circuit only. This output circuit. I'm in need of what now? Input is what? Shunt connection parallel. In parallel connection, total resistance will be? In parallel connection, total resistance will be what happen now? Decreases only. Whenever it is decreasing, we can write Ri by what? 1 plus A beta, we can write. Decreases only. Current indicates series connection. In series connection, what now? Resistance will be increased. I can write ROIF is nothing but 1 plus A beta times of 1 plus A beta times of R naught we can use. So these are the formulas are just enough in the feedback amplifiers only now. When you want to do the problems in the feedback amplifier, we need to use these are the formulas only now. Understand? What they are needed, I am giving you now. Understand? Yes, next ones. Suppose you are given any operational amplifier. Just a few formulas, whatever it is required. Whatever it is important, I will give only now in operational amplifier. But in the operational amplifier, an ideal case, suppose I have taken ideal, for ideal. Suppose it is an ideal only now, for ideal case only now. The op-amp symbol is taken like this. But internally, you can have DC sources, plus VCC, minus VCC, you will have, no doubt. Internally, it is there, you assume. This is nothing but the V0. The gain available from the differential amplifier is nothing but AD I have taken, for example. Differential gain or open loop gain. This is connected with V1. This is connected with V2 only. This voltage, we can call it as a difference of voltage, VD value. Difference of voltage, we can say VD value. What is V0? If I ask, you can use for ideal case, AD times AD into VD. Product of this will give V0. AD into VD. Generally, they will apply ED into VD1. AD into VD. By using this formula, you will get what is VD here? VD is nothing but difference of these voltage. V1 minus V2 they will apply. V1 minus V2. V1 minus V2 if it is taken, difference of the voltage is available. Then you can measure what is V0. The V0 is calculated by this formula only you can say. But an ideal operational amplifier has got one of the property only now. What is that now? The input impedance is always maintained very high. Input impedance of ideal op amp is very high. The output impedance is approximately 0 only. The gain of the ideal operational amplifier is very high, that is infinite value they will take. Bandwidth also infinite is possible here now. So whenever the ideal operational amplifier is taken here like this now, what is going to happen you ask? V1 and V2 only now. In ideal operational amplifier, certain points you will see in the questions only now. Next one. Suppose this operational amplifier, we are having the different applications only. It can act as a scale changer. Suppose it is acting as a scale changer. Scale changer means we can say inverting operational amplifier. Inverting op amp. If it is acting as an inverting op amp, how the V0 is to be calculated in the problem. But a scale changer means we can put like this now. There is an op amp here, minus and plus, this is a V0. This positive terminal is connected to the ground, here connected with R1, and here connected with V1. This is connected with a resistance R2. The network here given is nothing but this scale changer or inverting operational amplifier we can call. But by using the virtually ground concept only, we are going to do the question only now. Virtually ground concept means this voltage we can take it as a V plus. This potential will be taken as a V minus only. Under virtually ground concept, V plus is equal to V minus always. Those two potentials are same only now. And also what happened now in the inverting operational amplifier, how the V0 is to be calculated. How we can find the V0. Because of the V1, it is going to flow current. That current I will take it as I1. After reaching to this point, it doesn't flow any current this side. Why it doesn't flow current through the operational amplifier means input impedance is nothing but infinity only. Whenever input impedance is infinity, it doesn't allow any current through it. The total current will pass this side only. Feedback current IF. That means I1 and IF are always equal here. But how the V0 is available means by using this I1 equal to V1 minus, here I am getting V plus equal to what? Grounded here now. V plus is 0 voltage. V minus also same 0 voltage. What is I1 means V1 by R1. I1 equal to V1 by R1 you can use directly formula. What is IF I ask? V0 minus V0 divided by R2 only. But in the problem, it comes necessity to find out the V0 value. V0 value, whenever you want to find, you must use minus R2 by R1, minus R2 by R1 into V1. V1 means input voltage. This is the formula they are going to use to find out the output voltage. Sir, what is this circuit, sir? Here, what happened now? Suppose you are giving the V1 of what? Waveform such a way. But practically, R2 value will be maintained large. R1 is to be maintained small only. When the V1 is given, R2 by R1 is the gain. That gain times V1 is available. But output is a minus means with phase shift it is available. With gain of R2 by R1, the output is available such a shape only now. That's available. When I am giving the input of the sinusoidal waveform, you think so. Output is available with gain, but with a phase shift. How can you say phase shift is possible? Because of what? Minus only we can say. So wherever it is given inverting operational amplifier, you can use this formula. Because all the the problems in the the filter circuits generally they are going to use this formula mostly only now. Understand? The next one, non-inverting operational amplifier. Suppose non-inverting is given. Non-inverting op amp. Whenever non-inverting op amp is given, you need to draw the circuit in this way. The circuit will be like this only. Non-inverting op amp. But this is given this positive terminal is connected with a source. That source is given as some V1, for example. And I am connecting here the resistance R1 here. And one more resistance here connected R2 only. But this side we are connecting with the ground in this case like this only. Whenever you connected such a circuit in this way, we are calling this as a non-inverting operational amplifier. In the non-inverting operational amplifier, how the V0 you have to calculate in the problem. When you want to calculate means V plus and V minus are same. V plus equal to how much? Same V1. This is also same V1 under virtually ground concept. We know very well, whenever the voltage here available, same current will pass this side and this side, same current will flow. V1 is nothing but voltage across R1 only now. Voltage across R1 means it is a series circuit we are finding in this case. And V1 is nothing but voltage divider formula we can apply directly in the problems. How we can apply voltage divider? V1 is nothing but voltage across R1. V0 into, I can take V0 into what? R1 by R1 plus R2 I can use. R1 plus R2 I can use only now. But after using this one, I want to find the what is V0 value. How I can find the V0? If R1 is divided, I can get 1 plus R2 by R1 I can get. That into V1 I can do. Yes, I can use V0 of this value. Let's take this, you can understand. Not audible. Just 1 minute. Hello, sir. Hello. Sir, which side? Not audible, they are saying. Is it on stage or just now?
It's on from the FM. Not
No.
audible. They were audible.
Still not audible. Right now, okay. Now, okay. Yes, okay, I'll start now. Integrator circuit. In the integrator, I can put now this is grounded here now. This is connected with a resistance R and also connected with a capacitor. This is nothing but VI. This is nothing but integrator circuit only. Whenever integrator circuit is given, we can do in this way. This voltage is 0 voltage here. This voltage also 0 voltage only. This current is taken I1. This current is taken IF only. Whenever you want to find the V0 from the what now? Integrator now, we can take I1 equal to IF. You can use directly. I1 is nothing but Vi by R. IF is nothing but current across the capacitor. Current across the capacitor is C into dVc by dt, no doubt. C into d by dt of Vc is nothing but voltage across the capacitor. 0 minus V0 I can get. This is nothing but minus C into dV0 by dt we can use. Whenever you want to get the V0, dV0 equal to I can take minus Vi by R into dt only. Whenever you apply the integration, we are going to get the V0 only now. V0 equal to what? Minus 1 by R integral Vi into C also will come to down only now. Sorry, CR, RC will come. Vi into dt. Yes, we can apply this formula. Whenever integrated circuit is given, directly you can use this formula only. By using this circuit, output voltage you can determine only. Understand now? So for the integrator, this formula is required. If it is an integrate differentiator, what formula you can use? If it is a differentiator, if it is a differentiator, you must use this network only now. This network we can use. This is V0, this is connected to the ground, this is connected with a capacitor, this is a Vi here, this is connected with a resistance like this. Then we need to find the what now? V0. How we can find the V0? Differentiator means capacitor is at first. This current is taken I1, this current is to be taken IF only. Same work. V plus is a 0 voltage, even this voltage also same 0 voltage only. Even in this network, I can put I1 equal to IF. I1 equal to IF means current through the capacitor is nothing but C into dVc by dt, you know very well. Current through this resistance is nothing but 0 minus V0 by R only now. But a C into dVc, change of this voltage is nothing but Vi minus 0, dVi by dt they will use. So minus V0 by R. So whenever you want to find the V0, you think it's so, you can use this formula, minus RC into dVi by dt. So the formula you can use to find out the what now? V0 value. This can act as a what now? Differentiator one. If it is a logarithmic amplifier, if it is given, you can use this now. Suppose in a problem, if you got any logarithmic amplifier. Logarithmic amplifier means that network will be like this. There is an op amp, this is a V0 here, this is connected to the ground, this is connected with a resistance R, this is connected with a Vi, and it is connected with a diode. They will connect a diode only now. And we will ask to find out the V0 only now. V0, whenever it is required, you can use this current is I1, this current is nothing but the current through the diode. These two currents are equal, I1 equal to ID only here now. How I can measure the V0 here now? This V plus is 0 means V0 also 0 voltage only. I1 is nothing but Vi by R, no doubt. ID is nothing but current to the diode. Diode equation you know very well. I0 into e power voltage across diode by eta into Vt. Minus 1 will come. Minus 1 is a very small as compared to exponential function we are neglecting. Then diode voltage is nothing but 0 minus V0. Input minus this side. I will get minus V0 here now. Then I can measure directly Vi by R, that equal to I0 into e power voltage across diode is nothing but minus V0 I will get by eta into Vt1. By using this formula, you can measure what is V0 only now. So Vi by here I can find directly minus e power minus V0 by eta into Vt is nothing but how much? Vi by R into I0. And I want, if you have taken this side, minus V0 by eta into Vt, just wait once. V minus V0 by eta into Vt, when you want to find means log of ln of, what you will get? Vi by R into I0 I can get. Then finally I can say V0 is nothing but minus eta into Vt ln of Vi by R into I naught they can use. So like that, logarithmic amplifiers are used only, we can say. Understand now? So this is the span of time is the 4 hours. Within the 4 hours, we did the what now? These are the topics only now. Understand? So you try to prepare and get a good marks in the gate. So you try to go through the what now? This video number of times, you will get a good idea only. Okay then. Bye to all.